it's not enough to show the movement of Oumuamua, which is traveling over 160,000 kilometers per second in this case. And if I accelerate the time, if I do this, you'll see the minutes per second come up there. You'll see it's 39. Now we're going to increase it, and you'll watch Oumuamua start to move. Okay, here it goes, and we're following it. So I can slow it down a little bit because it's going to whip pretty hard. And now as we get closer, now we're following Oumuamua around the sun. Check it out. Here we go. This interstellar asteroid was 10 times longer than it was wide. And that's odd. And it came from way above our solar system, went down below our solar system plane, and then shot out above. This vertical line shows how far below the plane it is, right? And now it comes up, okay, above the plane pretty soon. And as it does so, you'll see that it whips off into interstellar space once again and is gone. It's just amazing. This thing was crazy. And so when it did that, it left our solar system far behind. And it's heading out toward the constellation, I believe, of Pegasus. Amanda, you remember when we actually did the discussion on Oumuamua, right? Mm-hmm. Yeah. And Oumuamua is a Hawaiian for scout.
Messenger.
Well, scout and messenger, yes. I saw both in fact. And both people that said it were absolutely certain it was messenger and absolutely certain it was scout. So I have no idea. I'm not Hawaiian. I don't know. But Oumuamua is a one-time visitor, and it's heading out again. And in Universe Sandbox, everything that we do in here is based on real physics. So the actual, like, here's the planet Jupiter. Now we're following Jupiter. And if we can zoom into Jupiter, all right, you'll notice it's spinning pretty fast. Well, that's because we have 1.17 months per second going by. If we slow that down, you'll watch Jupiter slow down. Okay? And now we have just 17 minutes per second going by. And you see the great red spot there? Remember that we had that Sky Tour live stream the other night, and Jupiter's red spot started coming onto the planet during the stream, came across, and we ended up with it was right about here. So that was pretty cool. Now, for fun, we can do some neat stuff. Okay, let's try something here. We can say add, and we say, oh, look at all the things we can add. We can literally add more stars. We can add a baseball, a basketball. We can add all kinds of billiard balls, but we can also add whole stars that are massive stars. We can add asteroids, any other planet, or we can just grab a random asteroid. So let's just take a random asteroid for fun. I'm going to grab a random asteroid, and guess what I'm going to do? Over here, it says launch. Okay, I'm going to launch it. So that means I'm going to launch it at Jupiter. So we're going at 17 minutes per second. So let's find out how fast this launch goes. And we click it, and there it goes. And it's heading for Jupiter. In fact, it's still heading for Jupiter because it started pretty far from Jupiter. All right, and as I click on it, all right, and I get closer, there's the asteroid heading for Jupiter, and then boom, it hits, and look at that. It actually makes a scar on Jupiter, just like Comet Shoemaker-Levy did on Jupiter, because that's what Comet Shoemaker-Levy did. It made that scar. And there's actually a simulation here in Universe Sandbox for doing the Shoemaker-Levy collision. So this is the kind of fun we can have in here. And I know you're all looking at this saying, oh, launch Uranus, launch Mars into... Okay, let's launch Mars into the planet, shall we? Now let's watch what happens now. This will be pretty cool. Look, we still have a scar, and we still have that expanding shockwave. See that?
If we watch it long enough, will the scar actually heal?
Yes, it does.
Like if we sped up the thing?
Yep. Yes, it will.
Yeah, that's cool.
Yeah, but now we're launching Mars. And Mars is going like, wait a minute, what the heck happened to me, man? What are you doing to me? And like, we can even see the shadow of Mars already on Jupiter. Because I chose to launch it from the side that the sun's on. Oh, here we go. Now it's accelerating, of course. Oh, look, we're going to hit this almost the same spot. Check this out. Boom. Whoa. That's crazy. And notice what happened. Jupiter shrugged it off. Because that's what Jupiter does. You know, Jupiter is very, very big. 89,000 miles in diameter. And this planet shrugs off anything you can throw at it. Now, I've had questions, and in fact, Amanda brought this up earlier before we came on. She brought on up the question of what would happen, and I'll explain what's going on here in a minute. What would happen if, like, a planet hit Jupiter? Would it actually go right through it because it's mostly a gas giant? And I said, actually, no, it wouldn't. Okay, because what happens is what we're seeing here, as the planet goes hits Jupiter, there's a massive amount of energy released. And Jupiter's temperature right now is actually increasing dramatically. And if we look at its surface temperature, you can see that it went up higher than 6,000 C, and it's finally starting to drop down. And if we accelerate the time, okay, these are the physics panels for this, and we can actually look at a graph of the temperature and see how it's actually dropping now finally, because it was actually way up there. And if I had this open before, you would have seen the temperature just go way up and then way down. It's just so cool. So let's say now if I was to just accelerate time again, we'll allow the temperature to drop. You can see now the surface temperature is dropping more rapidly because we're accelerating time. But you'll notice that there's a massive scar on the face of the planet that's now visible. See that? Mm-hmm. And that's going to heal over time as the cloud bands begin to come back. So let's accelerate time. Looks like it's getting brighter, actually.
But and Maddie wants to know if you can turn your mic up a bit.
Oh, okay. Let me do that if I can.
Are you reversing the rotation? Are you like rewinding it?
I'm not. I'm actually increasing the timing. So I increase the time here. So now you'll see that the temperature, surface temperature on Jupiter is dropping, and look what's happening. See, it's starting to return to normal. And we can actually, count the number of days it takes to do that. But notice that the scar on the surface of the planet, actually on the cloud bands, or the upper deck, the scar here, and I'm just going to drop this down to like almost now time so we can stare at this. The scar on this has actually been persistent for some time. And this is according to the actual physics. Okay, we can see how the cloud bands are trying to distort and come back through. But for the most part, they've been distorted greatly, and it will probably take some serious amount of time for them to readjust and come back to what they were. So this is what Jupiter would look like if a Mars-sized object hit it. We can do beyond this too. I'm going to change my mic a little bit just to make it a little easier to hear me. Ooh. Oh, it's Keith. Now, and so all of you know, Keith Ickes from P&K Space Imaging is here, along with Paul Gurnis from P&K Space Imaging.
Nice. We're still working on Paul. We're still working.
Still working on Paul.
Yeah, he's switching computers. He's going over to the other
Always switching computers. Okay, cool.
Yep. So I'm just popping back in real quick before I jump back out and get that settled.
That's fine. I'm going to now hit Jupiter with the Earth.
Yes, smash!
Here it goes. Hulk smash.
And we already have a request coming in, so when we get there.
I love this. We're going to have fun tonight. So here's the Earth, and everyone on the Earth is suddenly going, "What are you doing? How come I see Jupiter out of my bedroom window?" Okay, and all of a sudden it's going to be, we're going to increase the time now to, this is 5 minutes per second. And watch this. Now, hitting a gas giant is a little different than hitting a rocky planet. When you see that, it's going to be even more exciting. I promise. Here's the shadow, and here it comes. And oh no. Oh, what's going to happen to the Earth? What about my car? And then, boom, it gets absorbed into the planet. And as before, Jupiter just shrugs it off.
Like it never happened.
Well, I don't know. I mean, we did have, it did happen. Okay. Very clearly it happened. And so it's actually...
yeah, you think?
And it heats up the atmosphere a massive amount. Let's do something else. Let's actually pull out of this and go to the solar system let's go to look at our orbits. Okay, this is
We do have a request coming in
awesome
already. And guys, please keep the ideas coming, because there's a lot of things we could smash into a lot of other things. Possibilities are basically endless here.
And we want to smash a lot.
Hulk smash.
Charles wants you to hit Mars with Ceres. He believes it would be an instant atmosphere. Is that true? Can you touch on that?
We can actually see if we can do that. I know.
Why would that be an instant atmosphere? Where is he going with that?
I think where he's going is because Ceres has an awful lot of water on it and salts. He's thinking that maybe the vaporization of Ceres on the planet would actually allow for an atmosphere to be retained by Mars. But I think an atmosphere to be retained by Mars. But I think the thing that Charles might not remember, or maybe he is that the problem we have is that when a planet hits another planet, it actually causes quite a heat exchange, and that's a problem that we have to be wary of, because it's going to generate a lot of friction, a lot of heat, and that could literally boil off any volatiles that were needed. But we'll try it. Here's Mars. Let's go there. Vroom. Come on into Mars. Hello, Mars. I have the simulation paused. You'll notice there's a little play button down here. If I hit play, hey, slow down. Oh, thank you. Oh, man. Well, so now
if anyone was there, they just got flung off.
No, it's just accelerated. So what I'm going to do is go down to, let's see, an hour per second. No, let's go down to some minutes. Let's say, let's go down to, let's say, that's 1.4 seconds per second. Okay, that's not what I wanted. I want to go to just get up to minutes. Let's say, okay, 6 minutes per second. Let's see if this is enough to show us what we need. Now we're going to go there and say add, and we're going to say, any of these other things. Let's say, let's go.
We want series.
I know, minor, and this is series right here.
Okay.
And so now we're going to take series and we're going to level it at Mars. You ready? So
are you ready, Charles?
There it is. So now series is sitting there, and now we're going to start the simulation. And
yay!
Here we go. Boom. Boom.
Ooh, that was fast.
Yes. Well, I made it go fast. I mean, I could go slower. Now.
Yeah.
All right, we'll do it again. We'll do it slow. But here's what I want you to see. Okay. Mars has gravity, and these are fragments, and these are actual fragments, that are, they have their own mass, they have their own radius, surface temperature, okay, all the way down, angular velocity, everything. And so what happens is, obviously Mars got creamed here by this thing, and you'll notice that Mars has been had its rotation altered a little bit too. But we'll slow this down. And we'll
I want to.
Okay.
Yeah, slow them all down a little bit. You can speed them up again. We can do it a few times, but
yeah, you're right.
I want to see exactly what's going on.
Okay.
Because it almost looked like it was like a little play or something. It looked like there was it was being held on a wire.
Yeah.
And someone was moving it. Did you see that?
Yeah. But that was the path that was showing up. All right, so here's what we're going to do then. We're going to, instead of, let's say, let's do, not 4 hours per second. Let's do, what did we do? We did minutes, right? Let's do, I did 6 minutes per second earlier. Let's see what we can, well, we can always accelerate it. So here's what I'm going to do. I'm going to say 4.76 seconds per second. So we're going to go 4-to-1 speed. And I'm going to now add a minor planet. And that minor planet is going to be, see, minor. These are all the things you can add. You can add another planet. You can add a star. You can add, the common objects that you've used before. You can use moons. You can use minor planets like we will. You can add objects like teapots and basketballs and so forth. You can add whole galaxies.
Because why not?
Yeah, black holes. You can add objects you create. You can add rings, okay? And you can do this, which is cool. launch. And we're going to be launching a minor planet, but we're going to do it this way. We're going to say series here, and we're going to launch it actually. Now, here's what I just want to show you this. I could say orbit, right? And now if I said orbit, okay, we can actually then create a series in an orbit around Mars. All right.
Actually, Charles just asked that. Will the program show changes in the resulting orbit?
Absolutely. It handles the gravity and the physics perfectly. See, with this simulator, we can bring a pretend Nibiru into our solar system to see just what would happen if a massive planet came in. And you see how it upsets the orbits everywhere for years before you ever get to see it. And this is the kind of thing that I try to tell people, but, you know, they still want to believe it, and they have these little, these glaze over their eyes. And it's like, yes, I believe in Nibiru. Yeah, well, okay, fine. You believe in Nibiru, but it's not real. So anyway, let's just take series here and get rid of it, and let's go over here and do our thing. So now we're going to collide series with matters, and we're going to do it like this. We're going to say launch. We're going to take series, and we're going to do this. Okay. So now it's on its way, and there's an ominous shadow. You do not want to be under that shadow on Mars. You're going to like this because this actually does some really interesting, there's some interesting graphics associated with this. When this collides, you can watch the planet disintegrating slowly over the planet, and it does it, and you'll see a shockwave extending out. It's just beautiful.
Well, I remember we played around with this before, and I think it was just asteroids. I don't think it was anything major.
Yeah.
Or maybe it was a really big asteroid and it hit Earth, and it was slow motion, slow enough that you could just, I don't know. I guess it must have been causing like earthquakes and tsunamis and everything, and like you could see different pieces of the Earth lighting up. Like it wasn't just, it wasn't just like a smooth kind of spread. It was kind of like all sorts of areas were all affected at the same time, and they'd be popping up in.
I'm gonna pause this so that when you're done talking, because I had something to say. But no, go ahead, finish.
Sorry.
No, I want you to finish.
I'm finished.
Okay. Well, what I was trying to say was, this is 1.1, roughly 1.1 seconds per second. So in other words, it's almost real time. This is about how slow it would be. You'd see it lingering in your sky for like this amount of time. Okay, that's kind of how that would work. So I'm going to speed it up to get it to Mars and slow it down as soon as it actually gets there, so you can actually see what it does. There's sound with this too, by the way, and I don't know why we don't get the sound, but we're not getting the sound at the moment, and I apologize for that. And we might hear it, but man, it's just beautiful rumbling and stuff as these things get destroyed. It's just great. I'm going to just follow series, actually. All right, here we go. And we move in. Ceres is approaching Mars. Oh no, the end is nigh. It's almost like you want to play classical music, right, Amanda? Isn't it like you want to play classical music right now?
I'm thinking of the score to your movie. I don't know.
Da, 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 blum, blum, da, 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 blum,
no,
blum.
Not that one.
Not the Blue Danube Waltz?
No.
All right.
Da, 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 da.
Oh, also Sprach's Zarathustra, which is the beginning of that same movie, 2001: A Space Odyssey.
I figured it was from that movie, but I didn't know the name of it.
Very good, very good. You got it though. That's cool. All right, so we're going up. We're gonna go to about just do it in real time here. We can change it to real time too directly, but let's just do it like this, so you can just watch the slow motion how this all happens.
I just gotta say, I think I mentioned it last time we streamed this.
There it goes. Yep.
For anyone that's ever played Legend of Zelda: Majora's Mask, that was the scariest thing I've ever seen in my life. There's a moon with a face hanging over the town, and you have 3 days before it crashes in.
There it goes. Look at that.
And that's what it looks like.
Wow.
It gets closer and closer and bigger, and you're just waiting in doom.
That's right. And of course...
Like, what can you do? What can you do, really? Just watching that get closer and closer.
I know, and look at the shockwave already moving out from it. See that?
Yeah.
Yeah, there's nothing you can do, literally. But this is almost real time. So look at this is how long it would take for Ceres to like vanish into Mars. You know, and this is actually just a little faster than it would take. All right, and now what happens is, and this is the part that the program can't do quite perfectly yet. It can't do the debris associated with this, and I'm like kind of stuck here because it won't let me do anything. It's doing some funky graphic stuff that's not supposed to be there, so I'm kind of hung up in here right now. Well, so we'll just have to wait and see. Maybe I can actually accelerate us out of this. It was too much for the computer, apparently. Even my system, which is a very high-end system. Maybe I could just, if I can pull away at all. Yeah. These things here are supposed to be debris, but I think we're kind of inside the debris, so it's looking kind of funky there. Yeah, there's the impact scar. And I don't know what's going on over there.
If anybody on the P&K channel is wondering what's going on, we're just doing a simulcast with Marc D'Antonio over on his channel, playing in Universe Sandbox. So, if you want to check it out, like live, then you can jump on over to that channel and join us over there. I'm just kind of dual streaming it on here in case anybody just wanted to watch all the fun. So yeah, head on over there. I'll post a link in the chat for you.
And now we have another solar system back. I always start paused so that I can grab something I want to look at. So let's go back to Mars. All right, and we zoom into Mars again. And now let's do this again. Let's actually do we're going to fling, let's see.
Ray just wants to know what it would look like coming into Earth's atmosphere.
Ah, hey, that's a good idea. We already kind of looked at what it looks like at Mars. But why don't we go and pummel our planet?
Really hit home for the viewers.
Yeah, right? In a very scary
That's a pun because we live on Earth.
Right. There we are. Now, of course, if I start to play, okay, you'll see that it's spinning rapidly because obviously...
Aim south. No offense.
Aim south.
Well, I'm up north, so...
Well, I was thinking of wiping out Canada, but I guess, okay, I can do that.
No one ever goes for Canada. Come on, get out of here.
Hey, are you kidding me? What about, you got a large reservoir up there that's the result of a meteor strike.
So aliens don't like Canadians?
No, I didn't say
that what you're saying?
No, I'm saying that you have a large meteor that struck up in Canada. And, oh, by the way, that's the other thing about Universe Simulator, this Universe Sandbox. It's actually, if you go to 1-to-1 and you don't do this acceleration, it will actually show you the real night and day. So it can act like an actual virtual planetarium too. It's very cool. The stars are all real. The stars are in the right places. That's another thing about it. There's Hawaii. Oh, look, there's Kilauea erupting over there. All right, so let's throw. You want to throw Ceres at it again? I'll throw Ceres at the Earth. Okay, we're gonna do that. We're gonna throw Ceres at the Earth, and I'm gonna go down to 16 seconds per second. We'll go from here. Let's see what this does.
Because D has a question. Well,
oh, there we go.
A question, but I know you can do it, so
okay.
We'll do that. And I skipped her just because we were launching Ceres again, so I figured.
I'm gonna slow us down. As soon as we're ready to hit, I'm gonna slow us way down.
Because this is crazy. Because
look what I'm destroying.
This you can appreciate
Right now, people in India are going to all like be crazy, right? What are you doing? I'm sorry, not my fault. So this is again. This is like the. I'm gonna pull out now a little bit just so we can see what's going on. So there you go. This is real time. This is how it would look in real time. So you'd have plenty of time to see this thing coming in and hitting. And let's get it close enough to see what happens.
Has any asteroid this big hit Earth? Like the one that took out the dinosaurs? Was it bigger? No?
No, it was only a few miles across, not even.
Okay, so this is like never happened before.
Come on, what's it doing? I tried to pull away and it just still didn't let me. What is going on here?
A little planetarium doesn't want to.
This is not helpful because I was able to do up close before without any problem. So I'm going to do this again, and I'm going to figure out what I'm doing wrong because I have been able to do this before. What are you doing? Stop. Oh, this is just not
Earth
good.
was spared momentarily, but we're launching another one.
We're going to wipe it out anyway.
Oh, you know what?
What?
Ooh, I don't want to ruin anything yet because I think I know something that you can launch. I'm pretty sure I saw it in the list before.
Okay.
I gotta think of a good place to launch it though.
All right.
Give me really good ideas of places to launch something. I have the object in mind. I need a location. Come on, guys.
Okay.
Give me some good ideas.
Well, here's what I'm gonna do. I'm gonna. Hey, where's Keith, man?
He's still working on. And people are saying I'm loud. I'm sorry, guys. I just turned.
Well, and I'm not. Well, that's no good. All right, let's try this. Let's do this.
Okay, I'm turning it way down, guys.
Okay, so let's do...
Oh, I'm going to move my mic too. I don't know. Hopefully that helps. Sorry, guys.
Okay, let's do this. All right, we'll do it almost real time to start, and then I will change it off of here, and I'm going to back way out. And we're going to hit right in between, right in the middle here, right where the day and night side are matched up. And actually, let's just use an asteroid rather than Ceres. Let's do a small one, okay? Ceres is a minor planet. It's a dwarf planet. Let's do... What do we got here? We have many more than this. Let's do a regular random asteroid. So how can I do that? I want to do... I don't want to launch that. Reset launch keys. There we go. I'm not going to do that. Let's see. Oh, we can also create a ring around the Earth as well. That's fun. Minor planets.
Give me a good suggestion, Keith.
What's that?
Give me a good suggestion.
What's that?
On where we can lob something.
Oh, you want me to do that? Okay.
Right,
wait, what are we currently doing?
Oh, we're just launching a random asteroid at the Earth.
Yeah.
Like a big asteroid?
Well, not this time. It's actually a very small asteroid, in fact.
Okay.
But I'm gonna get closer to the Earth and launch it.
Ooh.
Yeah, this is
Make
better.
an asteroid hit New York. I'll leave that request anonymous, but if you want to take a guess at who requested it. No, that might get you in trouble. Don't do it. I take it back.
Doesn't matter. Everyone can.
It's only in public chat.
Everyone, yeah, right. I know, right? So
yeah, I know. But if he's guessing, he might say, "Oh, I bet it was so and so." Then they'd be like,
"All right, so this is
what?
a 2 to 1 speed." All right, this is a 2 to 1
Are we going
speed.
to New York with that?
Yes, we are.
Ah, there you go.
We're gonna smash it.
We're smashing.
How does my volume sound now, Keith? Do you know?
Better, yeah. It almost sounded like you could just like pull the mic like further away, you know, because it was like doing that kind of peak where you would hit certain things and it would like redline like really bad. But yeah, it does sound better now.
Okay, this is Orcus P. It's heading into
not New York.
Well, it's actually it was heading for New York, and you can see it's curving toward New York because see gravity is doing its dirty work. But the Earth is also rotating during this time, so Where it starts and where it finishes might be two different things.
Right. Yep.
Right.
I like what you're doing here.
Yes, that's right.
As long as it doesn't hit Sydney or Toronto.
It'll affect Toronto. You know what we want to do? I want you to watch the shock wave here. Okay, when it hits. All right, see that? As you watch the shock wave.
Yeah, it got me.
It got a lot of people. See, here's the thing. That shock wave is extensive. And also, that's a debris cloud that's throwing up there, see? See that right there? That's a debris cloud. And this debris cloud is going to be filled with things that are going to go up into the sky. Look, it's already gone all the way out to California. This is at twice real time, by the way. No, 4 times real time, 5 times. So an asteroid that large will do that. And then these fragments will leave. Some will go away from the Earth and never come back, but others are going to fall back and hit the Earth. All right. So even people around the world who didn't even know or feel this asteroid hit are going to see on their horizon this reddish glow heading their way, and they're going to go, "What is that?" And they're going to see this massive fire come toward them. Now, you'll see the secondary impacts of other things. Like there's a fragment there that's heading down and is going to hit somewhere. You can see several secondary impacts. There's the one there, and it just continues. And this shockwave. Now I'm going to go a little faster again. We're getting 5 times real time here. If we go faster though, okay, you can see again secondary impacts hitting here and there. All right, the secondary impacts. Now the entire United States, that one asteroid hitting in New York, has wiped out the entire United States. I mean, yes, there's still lights on because the program doesn't know how to shut the lights off. But see this? Okay, all these little fragments come down and strike the Earth anyway. And it could be very likely that when they hit the Earth again, they will heat up the atmosphere so much that the Earth will be incandescent and very, very hot. Could be 1,000 degrees, 2,000 degrees in the atmosphere when it's done. And the ground could end up being hotter than Venus. So that's pretty bad. Yet over on the other side, Australia's like, what happened? What happened? Anybody? And something happened. My call to Pennsylvania to talk to Keith was cut off, and that's why, because Connecticut and Massachusetts and Pennsylvania, they're all gone. But you'll notice, you see, these shock waves are traveling, and these shock waves traveling across the ocean are going to also do something else. And do you know what that will be, Amanda? What are these shock waves going to cause?
I'm thinking tsunamis.
You are thinking correctly.
Because actually I was just thinking that
look at all these impacts,
the orange or whatever color it is that we're seeing, that's only shock waves. Like, it won't actually show the water moving on the planet.
No.
Like, the program won't pick up actual tsunamis occurring or anything. Just the shock waves, yeah.
Right.
That's still really cool, though.
But you will, if you look at the parameters of the Earth, you'll actually see what happens. You'll actually see changes. You'll see, like, the temperature might rise and so forth. Let's take a look at the surface temperature now. Right now,
there's water pressure in certain areas. If you zoom in on them with it.
No, unfortunately, I wish it did that. But look at that.
I know I'm asking a lot.
No,
it does an awful lot already.
You should ask the things that you think of. But look at how the shockwave's expanding. I mean, this is just absolutely incredible. And so far, nothing in Australia has happened. Okay, we do have this one little fragment right here. And where's that one going? Is it in orbit? No, that's definitely... we got some fragments.
Rachel brings up a good question. Well, not question, comment, I guess. People were taking guesses at what that would cause. D said tsunami. Rachel's Toad saying winds. Would the shock waves going from, like, water to land cause, like, hurricanes and tornadoes and stuff?
Well, it would definitely cause massive windstorms. Okay.
Is that it? It wouldn't have enough power to Or like, well, I mean, I guess I don't really know how they form, but
there it is. See, Australia thought it was left out, and then that one fragment hit. Well, it would actually cause some phenomenal, high power winds, and the wind would be equal to or in excess of tornadic winds, tornado winds. But of course, over the course of the days that come, those winds would diminish because the firestorm itself, see, all these things hitting will cause fires. Okay, but you can see Australia was almost entirely covered with a shock wave. And you still see a shock wave up at the top of the Earth here, still making its way over Europe, because those are secondary impacts, you see. I mean, this is just, well, it's kind of a macabre thing to do, but it is actually really fascinating. So now some actually hit the bottom of the planet. So Antarctica is getting it's freeze off. There's more stuff coming in. See, so stuff would hit. Now let's back out a bit and check out the debris cloud. This is the debris thrown up by this thing. Now, is this exact? Well, of course not. I mean, it's just hypothetical, but it's very close to what might happen. It's very close to what might happen. Let's accelerate now and see how the Earth is going to look. Check that out. Kabam, bam, 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 bam. It's literally being hit so hard. Absolutely.
So
crazy.
in real time, how long is this lasting? Months, years?
Yeah, we actually have, there is a timer which tells us how long and I didn't actually, I don't know if I actually, I don't know if I actually did this. Yeah, I didn't do it. I'm sorry. I could have started the timer to tell you how long it would actually be.
Okay, next.
Oh, look at this guy going. Yeah, where's he going?
See? Look.
Ooh,
just when you thought it was over. I see another one in the distance,
yep.
but...
And another. See here,
will it hit the...
What that one is, this guy, little guy, is going to be, he's going to be doing something. Oh, there he goes, and boom. Oh, wow. See, so,
And none of them would ever get trapped in an orbit. They would all fall back to Earth. Yeah,
see, to get into an orbit requires a real special setup of circumstances. You have to make have a perfect speed at a perfect altitude for that, for that altitude, have the perfect speed rather for that altitude. And it's not likely that many of these would. Now, what could happen though, on the other hand, is we could end up with something like this, where we have a, let's say, let's see. Let's just do this, just for fun. We could have like a ring around the planet, and I guess I thought there was a ring there. I've added rings. How come this wasn't showing? All right, well, we could do it a different way. Hang on, I thought I wanted to add a ring. I'll do it this way. How about this one? All right, well, I guess we'll have to do something else, because I thought I could add a ring around the planet. I know I can add a ring. I'm just not sure why I couldn't at this point, because I've just been adding rings to planets left and right. But all right, no worries. I'll figure it out.
Okay. Dee had an awesome question, and like I said, I know that you can actually pull this off. Dee wants to know what would happen to Earth if the moon came a little closer.
Why don't we find out?
I was hoping you'd say that.
Yeah. So let's see. Let's start up a solar system. Or actually, no, wait. You know what? I got a better idea. Let's actually just get... Let's see if we can have... Okay, we have Earth and Moon. Here we go. Here's the Earth and Moon system. All right. Now, there's the moon out there. that's actually the right distance for the moon, you know. I know it looks like it's too far away, but let's give you an idea how far it really is, right? You see that? It's actually pretty good. Now, what I'm going to do is, let's do this. Let's change some of the settings. All right, so for instance, we know that we have a, let's see if we get this orbital period. I don't want to change the orbital period. I want to change the distance. Hello, Keith.
Ooh.
I knew it. I knew he was there.
What are we blowing up now?
I'm trying to actually I'm taking the moon, and I want to try and change the that's the distance of the moon. I want to change the distance of the moon, and actually I have the simulator paused. I'm going to change the distance. Let's change it to 100,000.
Change it to 100,000
instead of 300 and some odd. Okay, so now it's closer. Now it should be orbiting, but let's just find out if it's going to continue to orbit here. Yeah, so now it's orbiting closer. All right, and actually it looks like it's entered a highly elliptical orbit, but that's kind of cool because I want you to see what it does here.
Was Paul able to join us yet?
Yes,
Looks
Paul's
like.
here.
Hey,
Paul
Hi,
is here.
Paul.
Hi,
Hello,
Paul.
Amanda. Hey, Mark.
Welcome from P&K, the P.
He's
Yes.
the P from being
The
here.
man himself with the
That's right.
telescope down in Miami,
Yeah.
keeping afloat.
Yeah, it's actually cleared up a little bit down here tonight.
Cool.
The poor guy probably just went through hell trying to get that Skype to work.
I know,
Yeah,
right?
I did. I don't know why, but I had it all set up, but you know me with cameras, I never use this camera, so you know, that's why.
That's cool. What we're doing, Paul, is basically we're playing around in the universe sandbox and smashing planets together and whatnot. So just basically like a kickback night because everybody seems to be cloudy. But that's kind of cool that you're actually clearing down there. So you're telling me there's a chance.
There's a chance, yeah. I mean, there's some thin clouds that are going by and then clearing up and going by, but nothing like better than last night. So we'll see how it goes.
Sweet.
Oh, so what are we doing with the moon in the orbit here?
I was actually just trying to bring it close enough so that it would be within the Roche lobe and start getting destroyed by the Earth.
Oh, that sounds good.
You know. I know, huh? Yeah.
Hulk smash.
Eventually, that's what's going to happen, though, right, Mark?
Yes.
It's going to go way out, and then it's going to come back again, right?
Oh, actually, by the time it gets farther out, you know, it's moving away about 2 centimeters a year from our planet now. And this is a false orbit because I already brought it way closer. You know, but this eventually it's going to drift away, and people, you know, were thinking, well, gee, maybe one day we won't have tides anymore from the moon anyway, because it'll be too far away. Well, technically that could be true, but the problem is that the sun is going to die before that day.
Yeah.
And it'll be
Now,
a red giant.
weren't our tides a lot higher millions of years ago when the moon was closer?
Yeah, there was a higher tidal variation. You know, Bay of Fundy was probably crazy. Of course, the Bay of Fundy didn't exist, but you know, that's still true that the tides were a lot different. Boy, we're getting wild shadows in there.
There we are.
But of course, it wouldn't happen every day.
Now, when you brought the moon closer, is it going to be smushing Earth as it goes around?
No, but I'm going to do this. I'm going to actually, I mean, the orbit...
Do you know what I mean?
I do. Oops.
You just destroyed humanity.
I did.
Oh, my.
Did you see what happened there?
Oh, geez.
Yeah.
We're all dead.
I kind of went so fast that...
Just because of a guy with a computer, we have all died. Thanks, Mark.
Yeah, I'm sorry. Well, here's the thing. What I did was I actually... I didn't realize that... Well, I did realize, but I just did it. The calculations are only as accurate as the speed within which you live. And if we try to do it in a way that's a little bit faster, sometimes the calculations are inaccurate. So, for instance, if I want to bring the moon closer, okay, that's the moon, and we grab the data for the moon, we say motion, and we look at the different elements here. The orbital period is 27.3 days, semi-major axis, etc. I just want to make the moon closer. So what I want to do is do this. I'm going to actually take the moon, right? Take the moon and delete it. So now all of a sudden everyone on Earth is going, where'd my tides go?
And dead. We're all dead.
Right. But no. So what I'll do is this. I'm going to bring us down to the Earth. Okay. And Earth is happy, spinning away. Crazy here.
Flooding.
Yeah, right. And now what I'm going to do is I'm going to add and orbit a moon. And I can do that. Let's see. Where's the moons?
Oh, are you going to go to a bigger moon or a smaller moon?
No, we're going to go to our moon.
Oh.
See, now the distance, we can actually set a distance here. Let's try it nice and close. Okay, we're going to orbit it right here. All right, and let's see what happens. Uh-oh, look what's happening.
Oh, great.
Now look what's happening. See, let's slow this down. I want to explain.
That's what I wanted to see. The last time you got a little too fast.
Did it automatically name the new satellites?
It fragments, But see, here's what happens. Now, if you get too close, then the gravitational field, I'm going to go right to the moon itself here. The gravitational field, look, we already got hit, on this side of the Earth is higher than on this side of the Earth, and it literally pulls the moon apart. It pulls the planet or whatever apart. Oh, come on, not this crap again. I don't even know what this is doing.
Disco astronomy.
I have no idea what this is. This is like a bug. Oh, man, this is not right. This never happened before.
You broke the universe.
I did. So I'm going to bring it back again. I have no idea why it's doing that. I mean, I've never had that problem before. This is like
maybe
busted.
This is like NASA's new technology, and they're trying to shoot the asteroids with lasers.
Yeah.
Break them up before it destroys Earth.
Yeah, right.
Okay.
Pew pew.
Yeah. Well, let's do this again. All right. So now we come back. I don't know. I mean, I have no idea what they're doing. So let's see. Let's go back up to our Moony, and let's not launch. Let's orbit, and we're gonna put it. We'll put it out here and see.
Oh my!
Let's see what that does. All right. So right now we're not actually playing the simulation. We're just setting it in this mode here where it's just waiting, and now we go. And
we have a nice orbit as we go along, and it is gently rounding the Earth in the fashion that it does.
That's it.
And then all of a sudden, dead.
Yeah.
Mark, I got a question.
Yeah, Paul.
Now the Earth is slowing down, right? The spin.
Yeah, that's the
rotation.
Conservation of momentum happening there. Yeah.
Our days used to be a lot shorter. It used to spin faster, right?
Correct. That's right.
Okay. So in relationship to the moon pulling away from us, how fast is our rotation slowing down?
I don't know the exact number. That's something that I can look up and figure out. We're about to get hit again here.
Oh boy.
Yeah, that's Deimos, which is one of Mars' moons, and you'll see that it's going to be raping the Earth there pretty quick, and as it goes to the upper atmosphere. It might be okay. It might be just a very low, but
wait, did the moon spawn that?
No, I did.
Oh, okay. I thought for a second there, I thought it actually shot off the moon. I was like, what?
No. I put the moon in a spot where it wouldn't be destroyed, but I put it. See what's going on?
Oh my God! It's following the moon.
The moon is pulling Deimos along, and I want to do that.
It's like that dog that you go down the street and the dog starts following you.
Yeah. So see what's happening?
There it is.
Deimos becomes the wild card, and so the moon could actually stabilize Deimos. And what we see with many some of the moons in the solar system is that they fall into what's called a resonance, and I'm trying to see if I can get the moon to bring Deimos into some.
How cool would it be that like Deimos get caught up and actually start orbiting the moon? That would be weird.
Yeah, actually, we can see how that works. We can.
No. Let's just see through time, see if it naturally happens.
Okay, well, we can try that, shall we?
You know? Yeah. I mean, if we don't, it's going to get destroyed.
Oh,
Lord!
Oh.
It's a near hit. Oh, Jesus!
And see now, Deimos.
And there it goes.
No. Deimos is now in a. Is in a relatively stable in that elliptical orbit. Now, see, this might be a resonance, where for a number of orbits, it goes in this ellipse until the moon does a certain thing, and then it does that long set of orbits. Some of Saturn's moons do that in the rings, so it's pretty crazy. And then we have the moon, and then Deimos gets pulled a little bit, and that's going to tend to circularize the orbit. Especially if the moon comes along and right about here, this is where Deimos gets this follow through, and now we get Deimos doing the follow through. See what I'm saying? So
that's crazy to watch.
Right, and if we accelerate it, you'll see that we've created this this crazy, I think.
Well, predictable almost.
Well, it is predictable specifically, perhaps, and so. So you see what's happening now is the moon catches up, then this happens. See what's happening? Watch this. Okay, it catches up, and then whoa, it pulls it in, and now Deimos is coming in a little more, and now it's becoming. Oh, look at Deimos goes out, and it looks like long-term Deimos is going to be zipping around like this, and it could be circularized, or the moon could be affecting it in a way that's going to eject it or cause it to hit the Earth.
Let's add another one.
Oh, we will. Let's just watch. Oh, here we go. Oh, there we go. And now look what we got. And now it's back to this precessing thing.
Look,
right?
oh, it's dead.
Yep.
Done.
And it finally hit the moon. So this tells you, by the way, that.
So hold on a second. What's happening?
Wait a second. What we just saw. Okay, don't lose your question, Amanda. What we just saw is something that could have actually happened. Not Deimos per se, but an asteroid could have been captured by the Earth-Moon system, gone through this dance, and then over a course of a few years, billions of years, gone through this, and then finally struck the moon, which could be responsible for creating some of the largest areas on the moon that we see. So this could have happened already. See what I mean? So this is something that could have happened. But go ahead, Amanda. I'm sorry.
What? Well, no, I have to butt in because I always come up with way too many questions, and
I think
I'll
your
forget.
questions are wonderful, but go ahead.
Well,
and by the way, the moon is way too close. The moon is literally far too close to the Earth here. This is not how far it is. The moon is literally 20 to 30 times farther away in general. I just put it right outside that limit where it'll be destroyed by the Earth's gravity. But go ahead.
Okay, with Deimos.
Yes.
What was happening to Earth every time it switched its orbit?
Good question. Deimos will have an effect on Earth, but the gravity of Deimos is very small, and so I was trying to use something that was small enough, so nothing would have happened to the Earth. Obviously, maybe the day might have changed on the Earth. I'm not sure.
You know what?
So we'll leave these up so we can see anything.
Can we do something real quick, Mark?
Yeah.
Can we increase the moon's mass by 2?
Absolutely.
Right now, and just see what it would do.
Yeah, we can do this. We can stop the simulation, grab the moon, grab its data, and say, okay, it's let's do this.
And while Mark's doing that, in chat, what do you guys think's gonna happen?
See, it's 1 times now the size of the moon. It's one moon gravity. So I'm going to make it a 2.
Yep.
All right. Now you'll see a little bit of difference. It gets a little bit more massive. It gets a little larger in radius.
Okay, let's see what happens.
Are you ready?
You might have to zoom in a little bit because I think it will show the effects on Earth because I think it'll show the tides actually where they're hitting. I think when we did this before, it actually showed the tides pulling up on the continents.
Oh, yeah?
Yeah, I'm pretty sure it did.
Okay, well, let's take a look. Now, I'm going
let's find out.
Should we slow it down first, though, just to give
Yeah,
us
I mean, either way.
time?
Yeah.
Let's say 2 minutes per second passes. All right, let's see if this does anything. And by the way, you'll notice that the moon did not escape collisions with the Deimos particles. That's where Deimos hit. Isn't that cool?
So now the mass of the moon is times 2.
Mm-hmm. And that will affect the Earth as well. But from the top, okay, you see the Earth and the Moon system. You know, the Moon's going around the Earth this way, counterclockwise, and the Earth is spinning counterclockwise. So it's pretty interesting. Now, if I increase the time frame here, go a little bit.
A question in P&K chat that I just happened to jump. By the way, guys, if you guys really want to ask real-time questions, the best thing to do, I posted the link there, is to jump over to Marc's channel over here. Anybody watching in the P&K stuff. I didn't realize. But okay. Yeah, we talked about it.
Yep.
But astronomy and related video asks, why is the moon, the Moono, but I'm guessing he meant moon, not visible the hours before the eclipse starts?
Well,
look at that.
What's the definition of an eclipse? Okay, it's when the moon's shadow is crossing over the Earth, of course. But how do we see the moon's shadow? It's because the moon is on the same side as the sun, and it's passing between us and the sun, just like we saw there.
Look at that.
Yeah, and if we and when it comes around, I'll show you what I mean. Obviously,
I know, but just look at how it's look at the orbit.
The orbit, yeah. So here we see this. Now we have this. Okay. Hey. Oh, I wasn't even. I was elsewhere. Sorry. All right. So now when it comes around again, I'll show you what I mean. So when you pause it, okay, you see that? The reason we don't see it is right here. Okay. Now in this particular simulation, we don't have the sun. This is just the Earth-Moon system, but the sun is it's implied. But look, you don't see the moon, but the moon is right there. Okay, that's why, because the moon is, it's basically new moon whenever it's going to be a solar eclipse.
Yeah, right? And you got to remember, you're also trying to find it through the atmosphere as well of Earth. That's bright blue, right? You know, but where it's not really capable of seeing it, a new moon regularly during.
No, we can't see a new moon anyway. Yeah, that's right. And then off it goes. So let's do something else here. Let's take Phobos, and let's put it in orbit like this now, and let's actually
put it in a close orbit
around Earth,
like in between the two. Oh. Or didn't? That's what you do with Deimos, right? Deimos.
Yeah, I didn't. But
okay,
I'm gonna do this. I'm gonna go like this. Tink. All right, and now we have Phobos in that orbit, and of course, it's orbiting.
And remember, our moon is twice.
Right, but it's also, see, here's what's happening, Kate.
Oh boy, there we go.
We got whipped way out there, and there we are. Oh, is it already gone? Oh no,
it's like I'm out later.
Well, yeah, and it might very well be ejected. Yeah, it's true. But let's accelerate.
And that was a pretty high gravitational whip there.
Yeah,
it's gone.
Well,
screw you. I'm going to Mars.
Let's see. But yeah, check it out.
Moving through space.
Now you see, the faster we go, the less accurate the simulation is. So we have to be careful.
Wait. Is that basing upon our whole solar system's movement, or is that Earth actually moving? Like
this is actually based on the fact that the simulation is showing only the Earth and the Moon, but it's assuming, it's why it's implied that everything else is there.
Okay, so it's not like dragging the Earth further and further away from the sun?
No, there is no sun.
Okay.
See, we don't have a sun in the simulation, but it's implied.
Oh, okay.
In other words, it's there, but it's just been rendered invisible just for purposes of,
right,
increasing your computational speed, for this particular setup of stuff. So yes, so Phobos going in between Earth and Moon, it would get ejected. What does that tell you? It tells you that maybe there might have been asteroids that were there. So like, let's just put a whole bunch of them in. Maybe we did have these early on. Maybe early on there was a bunch of stuff that formed out here, right? And now what we get? Let's just go and see what happens. Oh, sorry, I was on. It is running. I just you can see the little trails. So you have trails on, so you can see the little trails of the things. Now here's the thing. This actually is a really good illustration. If you look at this object and you see the length of its trail, you see that? You see that this one's actually longer. There's a reason for that, obviously. It's because of the fact that the closer object has to move faster to stay in an orbit. So if we turn off the trails and turn them on, and now we watch the... Oops, sorry. I thought I was going to do them, I thought I was going to just reinitiate them, but it there is a there's a parameter for that I didn't do. But see, that trail is longer than this guy, and that's how this works. This is moving faster than this, and we can see that if we accelerate this. See that? And then, of course, it's going to hit the moon, or it gets pulled out by the moon. Who's banging on there it is. Boom.
Me, I'm typing astronomy into the P&K chat.
So the two inner ones were swept up by the moon. Did you see that?
Yeah.
Okay.
Can we throw Jupiter at all of it?
Yes, we can.
Or let's do something really dense, something really
a black hole.
Rocky. Let's do a rocky planet. Let's throw a rocky planet in the mix.
Yeah, that's Earth.
Mercury.
Actually, we had a question from chat.
Okay, what do you got?
Mario wants to ask.
Sure.
What is the smallest object that can knock Earth out of its orbit, if that's even possible?
Oh, Mario Lafreniere, I remember you. Yes, nice to hear from you. Nice to see you, Mario. The smallest object that could knock the Earth out of our orbit. Well, I guess what really you're asking is how fast would something have to hit the Earth to move it out of its orbit without actually destroying it? And I think it would have to be something that's pretty massive but small. So like maybe a neutron star could affect us, and maybe a super dense planet could affect us. But
and dead.
Oh, I saw it. You were looking at that. I know.
Yeah.
Keith is like, I can't wait to see something hit. I want something to hit. Something has to hit.
Well, yeah. I mean, that's the whole fun of, I appreciate the lesson. Don't get me wrong.
Oh, no, that's fine. So now if we do this, let's see. Uh-oh, now we got another one out there. See that guy? That
seems legit.
Yeah, it is legit. There we go. So, there's a lot going on. Okay, so now a lot of Phobos. Meanwhile, Earth is, being totally destroyed here. But it's okay. I mean, the Earth is still surviving. See, we still got our oceans. But you could, you could actually make the sun into a red giant, and as it swells up, you'll actually see the oceans dry up. Oh, it's just beautiful. One
thing we do have to try. The one thing I got it to do in Universe Sandbox 1, the original one, is I was able to fling a massive water world at Jupiter and make it ignite into a star. Now, let's see if they fix that nice physics.
Yeah.
I mean, it was a massive water plant. I mean, it was huge. But it did ignite.
Earlier today I made stars from asteroids that had hydrogen gas accumulating on them, and I just kept throwing hydrogen at them.
Go with Jupiter.
All right, you want to go with Jupiter? We can go with Jupiter.
Yeah, let's fling a water world to Jupiter.
Okay, let's go to Jupiter, shall we?
Let's do it.
All right. Let's see here. Let's do. Let's see if we got just Jupiter in here.
By the way, as soon as we are able, I'm pretty sure Paul is ready to get a good look at that nice planet of Jupiter once the weather settles down a little bit.
I mean, tonight?
Yeah, I'm pretty sure he's probably like me, getting itchy to freaking do something because, man, that weather, just East Coast weather, has been absolutely atrocious the last 3 weeks.
It has.
I'm actually going to set up here in a few minutes and get a quick in.
Cool.
Yeah.
Cool. And I will broadcast that on the P&K channel as well, and I'll have Marc in a little box there for you all. So if you're watching on P&K, you'll see the moon stream on there.
It is looking real good outside right now.
Oh, nice. Then we have to. We got to take advantage of it.
Alrighty, then we can all cut over to this and leave this one behind.
But I know your internet is not the best, Paul, so we would understand if you have to hang up in order to stream it.
Yeah, I'm just going to set up for now and let Jupiter get closer to Z.
Okay.
Well, while you wait, think of something we can smash into something else.
Yeah, right?
You should have the next request, because you're too quiet.
Absolutely.
Just don't kill Jupiter till I can get it in the scope.
Yeah, right.
All right. Well, then here we are. We're at Jupiter now, and here we go. Okay, so now we're at Jupiter again,
Now, Jupiter doesn't have any moons. Can we give it one?
How about this? Why don't we give it all its moons? Add moons to the planet.
And watch the lines of form.
Yeah, there's... Well, actually, I didn't even put those in, did I?
Oh, good.
Now, what would happen?
Wow.
Yeah,
what would happen if Mercury and Venus did have moons, and it was still circling the sun?
You know, we can simulate all that.
Normal.
But we can simulate all that.
Destroyed?
No, we can simulate all that. That's what I'm saying. We can just simulate it.
I know, but I want Paul to have a turn, and then I just jumped right in.
Okay.
No,
Ladies
it's
and
just
gentlemen.
Marc will say like a paragraph, and I have like 10 questions for every sentence, and then he won't say anything. It's like I'm overwhelmed. It's like I want to know everything. I don't even know what to ask first. I really don't.
Oh, that's the way it goes, though. That's the way it goes.
So sometimes these thoughts seem disjointed, but I may have been thinking about this for like weeks.
Yeah.
And then something comes up and reminds me, so. And sorry, I get it. I get loud.
That's okay.
Let's do a water world
out in, chat.
four times the size of Jupiter. Throw it at it.
All right, hold on. Let me wait. Okay, now we have Jupiter. So now these are the moons of Jupiter, and I got to turn on the trails, so now we can see the trails.
There we go.
Now,
and there is Jupiter moving through space and time.
What
I want to point out, though, is what you're looking at. Because when you're looking at the moons and the way they're orbiting, you're saying, wait a minute, that doesn't look right. They're supposed to be round orbits. They would be round orbits if Jupiter wasn't moving through space. These are the absolute trails made by the planets. Okay? So that's why they're doing what they're doing. All right?
Yep.
Now, that's something that, if you look at it right from the top, okay, Io is going around Jupiter, just like you expect it to. See right there, there's Io, it's going around Jupiter. And it's making a perfectly circular path around Jupiter. It's just that these corkscrew paths are what are the absolute paths left behind.
Mark, I forgot to tell you a story about today. I emailed the makers of this game.
Oh, huh?
Today, because of the conversation we had last night,
and they said don't.
And I asked them to put a flat Earth in, just so we can experiment. And I just went into detail. I was like, listen, we have a lot of things we would like to experiment with, just to show people how impossible it is.
And they told me there's no physics that can support that.
He emailed me back. It was basically, he said a nice paragraph, and he said in the bottom sentence before he let go of the email, he was like, but if anybody asks why we don't have a flat Earth or why we won't do one, just tell them it's retarded. And I was like, wait a minute, that's from a game developer. I was like, are you kidding me? I was thinking about screen capturing it, and I was like, well, maybe I won't, just because it was a private email between two people. But I was like, geez Louise.
That's great.
But I thought that would be cool to have, just to experiment, just to show people how impossible. It'd be cool if you put a flat Earth on there, and as soon as you put it anywhere, it just collapsed into a ball.
Yeah. Actually, that's the thing, though. See, because this uses real physics to work, you can actually show a craggy old asteroid, and as you add mass to it, because you can add mass and create a planet from just a craggy asteroid, as you keep slamming things into it, you'll watch it change shape, and there's a certain point at which it goes spherical, and that's because of the nature of how the accretion process works.
Paul, have you ever used this at all, or got a chance to play around in Universe Sandbox? Have you ever tried it or anything like that?
Have you ever played in a sandbox?
Have you ever played in the Universe Sandbox, I should say?
And
nope, still setting up.
Paul's not here.
Oh, no, I'm here. I'm sorry.
Okay.
The man is always working.
That's okay. He's in his mind, he's thinking, I'm going to set up this telescope if it kills me.
We'll take that as a no.
What did you say? What'd you say, Keith?
I was asking if you ever got to play around in Universe Sandbox at all, or ever seen it.
No. Oh. I've never seen it before. It's pretty awesome.
It is.
Yeah, it's awesome.
It uses the actual physics, and that's what's really cool about it.
And I think it's really cheap on Steam. You can, what was it? Universe Sandbox 2, I think it's on sale for $14 or something like that. And once again, if anybody wants it, definitely go out and grab it. It's a really fun tool to have. Yep. And, once again, we're not promoted by Universe Sandbox or anything like that. We just, I know I can speak for myself anyway. I really appreciate the game and the real physics and the math that goes into making this happen.
Right.
So definitely go and check it out if you get a chance. It's free, or it's on Steam for anybody to have.
As long as you use it at a reasonable rate, in terms of time, then it'll stay very accurate. As soon as you start to accelerate, it starts to take shortcuts.
Yep.
Because you're asking it to do 4 million calculations in only a 14th of a second, as opposed to 4 million calculations in about a 12th of a second or something.
Well, that's what I was going to say. You do want to use it on a computer that has very good processing power, because it does use a lot of computer when you're running it.
Yeah.
So because it is doing all those calculations.
Yeah. Now, see,
and is it worth it?
For each planet, okay, like here's Jupiter, like I said. We have this overview, so you can see all these things. And I'll show you something else now. When we're looking at the planet, you go down here and you see all these little parameters. It tells you the surface temperature at the top of the clouds. It's minus 155 C. Okay, the radius is this. Those are accurate. The density, the motion is correct. It shows you all the basically all the parameters of the orbit, amongst parameters you've never even heard of, like the mean and true anomalies. And then there's composition, which shows you the interior structure, and you can see that gives you the little indicators of how much iron, how much silicate structure, and how much water is within there, and how much hydrogen. You'll see that Jupiter is 98% hydrogen. It really is. Now, also, in that whole thing, okay, you can actually calculate and show the magnetic fields. For instance, let's look at Jupiter's magnetic field, right? It's massive. Okay, this is the magnetosphere of Jupiter. Now, why does it look like a teardrop? Because the sun's solar wind, way out there, there's the sun. The sun is actually streaming high-energy particles over Jupiter. And you'll notice that way out here, at the front end of the magnetosphere, these particles the particles from the sun hit here. And they never get to here. They never get to Jupiter. Right? Jupiter's magnetic field prevents the sun's very powerful radiation from actually reaching it. So it's stopped way out here, and it goes around Jupiter and leaves this little teardrop behind it. Okay, so that's the magnetosphere of Jupiter. That's the magnetic field. And it's a very powerful magnetic field, and we can look if we looked at, for instance, at the magnetic, let's see, turn on the magnetosphere again. Okay, and let's see here. Can I see the magnetic axis? Or is it down on the planet? I got to get closer, maybe. Well, it doesn't matter. Okay, the bottom line is that the magnetic field is what keeps us on our planet from having the ultraviolet rays from the sun hit us. But it doesn't protect anything on Jupiter. In fact, Jupiter, with the metallic hydrogen core, Jupiter produces a lot of radiation that gets trapped in its magnetosphere. So long before you actually reach Jupiter in your spaceship, you're going to be fried by the radiation trapped in its magnetosphere. Because look how far away it is here. And then look at this, okay, when we turn on the magnetosphere, okay, we are within it at this point. And
let's smash it.
What, the magnetosphere?
No, Jupiter.
Okay.
I don't like the way it's looking at me.
You know what? It's looking kind of... give me that little look through its eye. It's pissing me off. So you know what? Let's wipe it out.
Let's wipe it out.
And here's what we're going to do. We're going to find another Jupiter. No, let's throw Saturn at it. What do you want? Shall we throw Saturn at it?
Sure, why not?
Okay, let's throw Saturn at it. We're going to throw Saturn at Jupiter. Here we go.
We're going to say bye-bye.
Yes?
Ted wants to know, does Jupiter radiate anything at all except the magnetosphere?
Yeah,
gamma.
It does, actually. Jupiter has a infrared output. It puts out some heat. The magnetosphere has trapped solar energy particles in it. So that's why the magnetosphere is charged up in there and has this high radiation content, because it's a massive magnetic field. I think it's like 20 times ours. But we're going to fling Saturn now, and I'm just going to make sure that 20 minutes per second, maybe that'll work. Yeah, okay, good. That's reasonable. Now we're just flinging the planet Saturn. We're not doing anything special. Okay. And now we're going to see what happens here.
Dun, 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 dun.
That's no moon. That's a space station. Oh, yes. Here we go. And now Jupiter's going, wait. What did I do? What did I do?
Oh, this is going to be Mash of the Titans.
And I got to back off because I don't want this to do this to me.
Oh, for bam.
Yeah, but look what happened.
Watch the moons, people. Watch the moons.
Okay, here we go. Oh, yeah.
Utter chaos.
Yep. It is definitely chaos.
And I bet you if you were to back out, it would have an effect on the entire solar system.
Well,
eventually.
It may. But look at this.
Well, we just almost lost our great protector, but Jupiter stands and Saturn is gone.
Well.
Now we have Stupider.
Or Jattern.
Jattern or Stupider.
I like Stupider better. That's funny.
But look at it. It's crossing. It's going. It's Europa's still hung around for a little bit. Ganymede.
Yeah, but I think what we want to do is accelerate and look at the time to see if anything stabilizes out of all this.
Okay, I'll do the play-by-play.
And as you can
as
see,
Jupiter rides through, we're watching Europa.
Now, Jupiter has been accelerated, and it's been accelerated in the direction from which Saturn hit it.
And it's heating up.
It's left the moons behind.
It said bye-bye.
It said bye-bye. That's right. Yeah.
And as we have a little creeper that's deciding to stay around Jupiter as a hot mass traveling through space and time.
Let's pause this and go check that out. Oh, that's Metis. Look at that.
We have found Metis, the one little clinger to our new stupider planet.
Right. Now, if we look at the mass here, okay, the mass now of this planet, let's go back to overview. The mass of the planet, now if we look at it in terms of mass of Jupiter, all right, it looks like the mass is down to 0.2 times that of Jupiter. But that doesn't seem to make sense, does it? Because we took Saturn and collided it with it. But what happened was a lot of volatiles were just burned off and destroyed.
But make no mistake, it is glowing, but it is not a sun.
It
is not a sun.
No, doesn't it look like a snake slithering?
Yes, it's very creepy.
It is very creepy, yeah.
It's like, you're going to leave me behind? No, you're not. I'm coming back up around the other side.
That's it. And meanwhile, this scenario played out in our solar system. Look at that. Look at all the stuff left behind.
Remember all the ships coming to Earth in the battle in Mass Effect 3? That's what that kind of looks like.
That's right. And now anyone who's played Mass Effect 3 knows what you're talking about. Those who didn't say, what's he talking about?
Wow, look at that. We got Europa and Ganymede still hanging out in the back. And we have, I'm trying to find one of the bigger... I'm trying to find where all the Galilean moons are.
Well, Ganymede and Europa are here.
Okay, yeah, we have those two. Now, where are the other two?
We need Callisto.
Did they get destroyed? Are they out? Are they...
Not sure.
Wait. Saturn's there, too. Go back over to the right.
Saturn?
Saturn is right there.
Where is Saturn?
Go to it. To the right. Up.
Oh, there it is.
There it is. Let's see what it looks like. Saturn survived a collision.
No, it didn't actually survive
with the protector of the inner planets.
It didn't survive.
Mark, don't destroy my dreams right now, okay? It's there.
Yeah, well, it's there, but it didn't come out of it. It's not like it went through. I'm not sure how this. See, this could be a syntax thing based on the labeling. Actually.
Okay, well, maybe my play-by-play was wrong, but I saw Saturn and
just
taking it.
I'm going to send Venus into it so that'll end your...
Maybe it's a black hole.
I just sent Venus into it so that ends your trip real fast.
It's a black hole.
There it
goes.
Look,
it's glowing.
I know, because I sent Venus into it and the friction...
So it did survive.
Well, I don't know. Anyway, I am going to... Let's see, what we got over here?
Well, before we get too far from Jupiter, Ronald wants to know what kind of storm.
Ronald who? I'm just kidding. Look at this.
Look at it.
This is what's left. This is what's left in the Jupiter system.
Would you look at it?
That's crazy, isn't it? all these little planets. Look at, there's Europa.
And how fast did you throw Saturn into it?
I don't know what the default speed is. It might have been 10 kilometers per second.
But Europa's still hanging around.
Europa's
just
there.
moons without a home. I wonder where they will go in time, where they will find their way to.
Well, shall we look?
Let's look. Let's find out. That's why we do this. Everybody in the chat, we're going to find out what happens to all this debris. Will it make another moon around another planet? We don't know.
Will they collide with each other?
Yes, you never know.
Yeah. Will their mutual gravity cause them to coalesce?
Are you at the? You probably have to take speed up a bunch.
Well, here's the thing. See down here. You see
yes, but as much as you can, I should say.
This red thing here.
Yeah.
This basically gives us the maximum time step.
That's weird because you know what? I have never had that happen.
Well, I can't. I can get to like. 17.
I wonder if it's maybe something new they added to an update or something.
Probably, because it was just dragging people's machines to a halt.
Yeah, understandable. I mean, it'd probably just all the calculations that have to be done to do it, like 10 years a second. You know what I mean?
Now, if I come farther away, I wonder. See, now that we should be able to get to a little higher than that. Let's see. Yeah, we can go to almost 18. We have to go even farther away. And now see, it's dull again, and we can actually probably go to maybe 20 or so. No, it doesn't let us. No. 18 is the limit.
Okay.
So we've had a solar system that was disrupted fairly. Look at that. That's just like.
That would be so visible in our night sky.
Oh, well, yeah, it would. I mean, those aren't visible trails. This is what you'd see. Okay.
Yeah.
This is just trails that we had.
I'm saying the initial impact and afterwards we'd have a massive light in the sky.
Oh, yeah. Actually, let's go to the Earth and see if anything.
Did you ever answer Ron's question?
Ron's? No, I haven't answered that yet.
Oh, okay.
And I'm going to ask Amanda to ask me again because I didn't hear it. I mean, I heard it, but I was in the middle of a thought.
What? Sorry.
No,
I didn't realize.
That's my fault.
I thought you were going far away. And I'm going to keep it topical. And other questions are coming in. I'm trying, guys.
Let me answer Ronald's because he did ask a question. I didn't answer it. What did he ask again?
He wants to know about what kind of storm that red spot on Jupiter is.
Well, that's the thing. We don't. Yeah, well, that's true. We don't know what type of storm it is per se. It's not like we can say what it is. We don't know what it's from because we don't really understand. We have an idea what. Look at Saturn out there. Hey, look at me. We understand what drives Jupiter to some extent, but we don't understand what drives these large storms. For instance, there's white ovals also on Jupiter, and those are also storms. But we don't know the exact weather mechanisms which drive those. There's a whole nother thing.
I thought it was like the eye of like a hurricane or something.
Well, no, that's all true, but we don't know what causes it. I think I thought his question was asking what causes them, or.
Well, he's wanted to know what kind of storm it is, so I guess, yeah.
Oh, well, what kind of storm?
Well,
it's a cyclonic storm of some kind, but there's one set of footage you can look at, which photos actually, which shows the red spot from above, very close, from one of the Juno mission probe photos. You can see it spiral down into Jupiter. So the reason it's darker is because you're seeing down into the deeper recesses of the planet. So it's not just like a cloud that you're seeing at the top of Jupiter's atmosphere. You're actually looking down into Jupiter's atmosphere because it's in 3D, you won't forget. It's really cool. I'm going to just do a new one here, by the way, and there's a reason. All right, here we are. And now we want to
thank you. I hope that helps Ronald.
What?
No, I was saying thank you, and I hope that helps Ronald.
Okay. This is a main sequence dwarf. This is an M star. Okay. And it's a star that if we look at it and we grab its properties and we look at its size in terms of the size of the sun, all right, it's only 0.44 times the size of the sun. It's less than half the size of the sun. So what would happen if what would happen if the sun actually struck it? Shall we find out?
Let's
do it.
Okay, we're going to do it. So, we're going to launch the sun at that red dwarf. And this is 1.3 hours per second. We'll have to increase. So, there we go. Now we have these two stars heading toward each other. Let's watch what happens. We shall now increase the time. It's still your turn. It goes exponentially very quickly, so hold on. What the hell, this stop?
I know, right?
Oh, the duh. I got the look, hello. Simulation's paused. Okay, my mistake. I apologize. It's all me wrong, guys. Sorry. It's me. I'm wrong. I'm sorry.
You were just building the anticipation.
Yeah, it's so much so that I screwed up. Okay, so now I'm going to say go. Boom! What the hell was that? Well, let's back out to see what just happened. Whoa, this is called a supernova. Now, here's what's interesting, folks, about this thing. You see this? Now, we're not traveling. It's coming toward us because the supernova is blowing outward. So the supernova occurred inside. But you see all this material in here? You're not going to believe this, but this is material that we can actually use to build new star systems and planets actually in Universe Sandbox. You can use this. This is all hydrogen gas. Okay, and it's all very, see supernova remnant. It tells us what's in here. Okay, this stuff, it gives you the mass, tells you where it's from, and this is all the star stuff, the elements and so forth. And we can actually now build another star from this. And it's just crazy what we can do. And I just absolutely love it. So if we put an object in there that had some gravity, it would start pulling all these little supernova remnant gases and particles into it. And it would actually create a brand new star. So, but if you accelerate now, you'll see that it's expanding outward until finally there's nothing left behind. And you'll see it go dark in just a couple seconds. And now, if you notice, the material is still here. All right, if we actually, if I just drop down the time here, not that we have to, but if we just drop it down like right now, let's just drop it down to something reasonable. Here we go. Okay, so, and all around us now is supernova remnant stuff. It's all here. In other words, all the material created in the star is around us, so we can actually create stuff from it. And this is very cool. Now, let's take the sun, for instance, and we'll stick it out. Okay, I launched the sun. I didn't mean to do that. Okay. So
you just killed a civilization.
I just launched
way
the sun.
Far away.
Yeah, I launched the sun. That was a little bit bad. Okay. And
is Paul still here?
I think he dropped out.
He dropped out. Okay, I was just wondering because I actually have the stream ready to go on this end.
All right.
So,
cool.
Maybe not.
Paul, if you're still listening, the stream's ready to go on this end. So.
No, maybe he's still there.
Yeah, you never know.
Okay, so now, here's something. We can actually create a binary star system. And there it is. Where to go?
But can we smash it?
Oh, yeah, we can smash it. Yeah, we can smash it. Yeah, we actually got too close there. So, let me
do something real quick, Mark.
Yeah,
Anybody that's watching on P&K, Space Imaging right now, if you want to continue to watch this playful session on Universe Sandbox, please jump over to Marc D'Antonio's channel. I will post a link in the chat. The P&K stream will be shortly switching over to the live moon, since we will have it for a little bit. And so anybody wants to see that, they can hang out there. If you want to keep on checking in with the Universe Sandbox session over here on Mark's channel, jump on over. The link will be in the chat. And thanks.
That's funny. Thanks.
There you go. Very good.
All right.
Continue, sir.
Sure enough. So
I'm just gonna. I think I'm just gonna hang out on mic with you guys, even while we're streaming the moon. Okay. You know, I'll be kind of clicking back and forth, but you know, I still find it interesting. Let me post your link in our chat one more time.
Okay.
So people have it for them to continue watching us playing in the sandbox of the universe with total destruction going on.
Absolutely right. I'm going to pull out of here for a minute, and I'm going to throw in Proxima, kind of an approximately where it belongs.
A quadruple star system.
Triple. Doesn't need to be quadruple, but
let's
see,
let's see if I got it. What'd you say?
I was going to ask if we could see something, but I can't remember what it's called. I can't remember where it is. But it's something's Trojan.
I would guess.
And there's three stars that go all in a row.
Yeah. I'm not sure. I think the Trojan things are the asteroids. We have the Trojan asteroids, which and the Apollo asteroids. So, is it that? Sounds like Keith is drumming.
No, I'm typing.
Yeah.
Because I can't do anything else because of the stupid arm.
Yeah.
Yeah.
It's okay. Okay.
Is it in a cast?
Huh?
I asked Keith what happened to his arm, and he left. And I asked him if it was in a cast.
No, it's a microphone arm.
Yeah, the mic arm, not the...
And the way I have to have this set up, I have the laptop that's actually viewing the 2 streams on YouTube. It has to be connected to that table. So anytime I type, you'll hear that, which is crappy.
Yeah, that's not a problem. I was trying to just generate the Alpha Centauri system, but I mean, it's already generated. Let's see that. Boom!
And goodbye.
Oh, wow. Yeah, I
just killed all of us.
Well, the problem was I couldn't get the third star to orbit properly. I'm just having fun. I actually.
What would happen if we put like 10 stars in one area, like far enough away at first, but just put like 10 stars in one general blank canvas?
Well, let's find out, shall we? But first of all, let me look at some other fun collisions. Let's see. Sun and the Earth, Wolf 359 in the Earth, Jupiter and the Earth, Mars and the Earth, Moon and Mimas. Mimas, you know, the moon there, Saturn. Earth and Moon, Earth, Moon, slow motion. Here we go.
So many questions I have. Can you... I think it was when you moved the moon's orbit closer to Earth and it all broke apart.
Yes, that was the rotation.
And I think Keith was saying something about, would it make a new moon? Can you do that here? Can you, like, if you sped it up, would all those little portions... I don't know. I don't even know how to ask because I have so many questions. Like,
would they accrete and become a new moon?
Yeah, like what's...
I don't think that
what makes it that some would just like crash into each other and explode, and some would like clump together and, you know,
yeah,
size,
it's circumstances actually. The circumstances of the motion, you know, pretty much. So let's see.
So we were talking about it a few weeks ago on Sky Tour Radio. Plug.
Yeah,
and, you know, how the planets were formed, how the sun was formed, how the moon was formed. And I'm just wondering, can we actually watch it on this program?
Yeah, I'd have to research that to do it right. But I can try, you know, after that point. But,
just a thought.
No, it's a good thought. I like it. Remember, folks, Sky Tour Radio, 9 p.m. Eastern Time on kgraradio.com. And we've actually, when in looking at the ratings of Sky Tour Radio, I've been kind of astonished at how well it's been doing, and very humbled too, because it means that people are actually you know, listening to our broadcast, and I'm very, very pleased because, you know, these are nationwide rating, actually worldwide ratings, and if you look at our ratings on what's called TalkStreamLive.com, for our time slot, which is 9 to 10 on Sunday nights, our rank has never really has never been higher than 4. It's always been 2 or 3 or 4, and mostly 3 on average. Isn't that correct?
That is correct. Yes.
So that's pretty good, and it's all because of you, Amanda.
I doubt that, but thank you.
Don't doubt that, Amanda. You know, you actually have some really intelligent things to say, and you ask questions that other people are actually thinking out there. I know it.
Oh, I hope no one has the kind of crazy thoughts I have, but people need this, whether it or not. Either they want it or they hear it and they don't realize how much they needed it until they heard it, you know? Like,
yeah. Well,
these kind of things matter, and they, you know, like, I don't know how to explain it. It's like, it's the building blocks of everything. It's all around us. And I don't want to get too deep and philosophical.
Well, you're allowed to. You're allowed
But
to.
you know what I mean? Like, I don't know.
Well,
you can really dream crazy things in this kind of universe, and you can actually think of how to make it happen. Yeah. Sorry, we were talking about consciousness last night on the show, and
we had a very interesting talk last night on the show, because my big thing was, you know, the life on this planet seems to have followed an evolutionary pathways that make the existing life very special and very able to survive within its niche for its evolutionary adaptations that's undertaken. And I use the octopus as an example. The octopus is probably one of my favorite animals, although it frightens me to death. The octopus, if one wrapped around my leg, I'd probably scream like a little girl. Ah, you know. I'm just waiting for that parrot-like beak to start gnawing at my ankle bone or something. But the octopus is very intelligent, and I think the studies show it to be, perhaps, and some oceanographers and scientists agree, it's the smartest animal in the ocean, right, Amanda? You know. By the way, I'm going to do a 14 seconds per second just to see if Siri's hitting Siri's will do anything for interesting. So it's just these
Siri's
two.
Hitting Siri's?
Siri's hitting itself, yeah. So what would happen? Let's find out. And I'm going to stay far away because I don't want any of these video artifacts happening. I'm going to figure out what's causing that, because I used to be able to be right up close, right in the middle of this, and watch it happening, and didn't have any problems with it, with this very computer. So I'm not sure what's going on. But here we go.
I think the one moving is going to make it better.
Oh. Ooh. Look at that. And this is faster than real time. And then, of course, Siri's explodes into these many fragments. Look at that. That's just beautiful, in a sense. Frightening and beautiful all at the same time, don't you think? Now, it's going to merge.
It's going to merge together?
Yeah, well, see, what happens is, what will happen is the planet will actually have a tendency to just become molten again. And that's what we're seeing. And by going molten again, the planet will then form a larger round planet. I mean, the dwarf planet, rather. And then you see these things
Your
flying.
sound's breaking up a little.
Huh? What? What did you say?
Uh-oh.
Why?
Your sound is really broken.
Well, let's make sure that it's not just at your end.
Is Keith still here?
I see him. You see him?
No,
here.
it's still it's on your end, Mark, because I can hear Amanda just fine.
And I'm breaking up?
You're breaking up and the screen was freezing. So I'm thinking your computer is having a tough time running Skype and, simulation.
I see.
At certain points.
Maybe that collision was a little bit bad.
It's possible.
Yeah.
That's what happens when you smash series into series.
I guess so. Well, here's what I can do. Let me just go back and say new and see if the problem is gone. So is the problem gone now? You can hear me fine now?
Yeah. Coming through pretty good.
All right. So it must have been my attempt to smash series into series. Yeah. That's too bad. I like smashing series into series.
No, other people are saying they could hear you. I don't know.
Huh, that's strange. Well, no worries.
Weird.
Well, it seems like it resolved now. Okay.
Yep.
Keep on, sorry.
All right, no worries. So, I was talking about from last night's show when we talked about the octopus as an intelligent animal. I was just very impressed with the octopus, and so I think that people will generally think that the octopus is a highly evolved animal as well, and science does too. So it's pretty cool. All right, in this simulation, the Earth crashes directly into and is swallowed by a black hole. That's the mass of the sun. Okay, shall we see that? And it says 1 minute per second. That's probably going to go fast, so let's do this. Let's drop it down and see what we get. We can always increase it in speed. And don't forget, we can't see the black hole. But the Earth is heading toward it, that's for sure. Oh, wait a minute. You can look for the black hole. You can actually see the way it warps the stars. Okay, so... Uh-oh. You got all that noise? Look at this. The Earth is actually being broken apart. Uh-oh. Well, that's it. It's gone. Well, that wasn't very exciting, was it?
Thanos.
Wasn't very exciting. Yeah, I know. It just was not too exciting, I guess. But you know what? We'll try that. Black hole in the moon. Well, let's try the black hole in the moon. Is that any different? Probably not.
Okay, what is the biggest moon out there? Ganymede?
No.
Titan?
I think our moon is the largest moon, isn't it? No, oh, you mean as far as the,
in our solar system.
Oh. I'd have to look at Titan's diameter, compare it to Ganymede. Because I think Ganymede edges out Titan by a little bit. But I could be incorrect. But I do believe that Ganymede is the largest moon in our solar system. That's
okay, those are my first two guesses. That's not too bad.
Not at all. And it comes from, you know, having been exposed to this. You know now, you know?
That's the thing. If I can pick up a little bit each time,
yeah,
then, yeah. And just not forget it. I can't take in new information and forget the old stuff, right? So.
No, you can't. And you won't.
Okay, I have
just so you know, I mean, I'm almost certain that Ganymede actually is the largest moon in the solar system. And you know, I think that Titan is probably next in size. So they're, you know, there's Ganymede and Titan are very close in size. Okay, but I believe Titan is a little bit smaller than Ganymede. So.
Unless Paul's still around and he has a request. I have a request.
Okay.
Okay, I hear nothing, so I'm gonna.
Yeah, I don't think he is. I think he's getting ready for the stream.
Okay.
Yeah, he sees clear sky, and then he's like, ah, clear sky.
Oh, I don't blame him.
I don't either. I'll probably go outside and see it's clear here too.
Okay, I want to see Titan.
Okay.
No, Ganymede, sorry.
All right. You want to see that, huh?
I want to see Ganymede.
Okay, so to see Ganymede, we have to first bring up Jupiter so that we can see Ganymede. So what we're going to do is we're going to look
But I want to launch something at it, so...
Okay, well...
You're going to have to take everything else out.
Well, then let's find a... There's one of these that actually has just Jupiter in it. And I think... And like we have the Saturn system. Okay, and I know we have the Jupiter system down here somewhere. Just Jupiter. Yeah, so I'm trying to find that.
And this is a free program, right?
No. This is a program. It's a paid program.
you have to pay to use it?
You have to pay.
No, it's a single download. It's like $14 on Steam if anybody has Steam for like gaming or anything. You can get it and download it.
And there's no free version. Someone else, Maddie, was asking. He can't get it on his iPad.
No, because it's a
anything,
PC-based program. There might be a Mac counterpart, but they're not. I don't think it's written for iPad. It's way too computer intensive for.
Yeah, if you go to Universe Sandbox website, I'm not sure exactly what. It might be universesandbox.com. I'm not sure, but go in there and look, and they'll give you all the options and tell you what kind of processing speed you need and whatnot in order to for it to work properly.
Right.
Thank you, Keith.
So everything you see here is Jupiter and its moons. Check it out. Way in the middle of all that is Jupiter. Isn't that crazy?
That's very crazy.
And of course, here's Europa. Here's Io. All right. And I believe if we swing around, we've got Ganymede there. Okay. And Callisto is right there. So there are the 4 Galilean satellites right here. Callisto, Europa, Io, and Ganymede. And you want to see Ganymede. So let's go zoom in into Ganymede. Okay, here we are. This is Ganymede. That's actually what it looks like. That's the real Ganymede. And what did you want to smash into it? Well, first of all, let me drop the time down to something more reasonable. Okay, 7 seconds per second. That'll be good. What do you want to smash into it?
And because I was alluding to it earlier, and then my friend Ben showed up in chat and had the same idea. So
okay.
The Death Star, please.
Oh, I don't know. We can do the Death Star.
I'm sure I saw it in here before because I remember thinking how funny it was.
Really?
Yeah.
All right. Well, let's go to the objects then. The objects tab. And let's see if...
I mean, you have billiard balls and soccer balls and stuff.
Yeah, but those are the actual size of a billiard ball. No, that's not huge. We have the New Horizons spacecraft. Let's see. Yeah, I don't see it. We have the Tesla Roadster. Look at that. Talk about you know, being updated, right?
Ooh. I want to send that by Pluto or something.
Remember, it's the actual size of the object, so it's, you know.
Now, if we sent it from Earth and sped it up, would we actually see the car like discoloring and breaking down and stuff?
No, I don't think they handle the radiation. I don't think they do. Look, we could throw jack-o'-lanterns and so forth. We can shoot New Horizons. We can throw a Phantom Zone from, well, and we can throw third stage. Why would they say third stage of Saturn V? Why would that be something that you could throw at the moon, you know, or any other thing?
I don't know, but seeing that, I'm sure there's got to be a Death Star in here now.
I'm going to interject real quick and just let you know, Mark, I'm going to dip out of this call just so we can stream over there. I'm going to try to save some bandwidth. That way I'm not running Skype when I do it. So,
okay,
guys, have fun. We'll be over streaming the Moon and Jupiter.
Alrighty.
Have fun, guys.
10-4. Smash some stuff.
We'll get there.
All right, guys. Have a good night.
Ya.
Yep.
They show the third stage because the third stage of the Saturn V was the one that held the lunar module, and after they extracted the lunar module, they'd crash it into the lunar surface, and it would actually make a crater, and that crater would set off seismometers left by other missions, and they would actually be able to test their geological model of the moon by those crashes. And it was very interesting, and you can actually see on the Lunar Reconnaissance Orbiter website, which will be another cloudy night stream that we do. You'll actually be able to see the third stage crash sites, and I'll be happy to show them to you. I will be happy to show them to you. But here, you know what we're gonna do? Let's do this. Let's just for fun. Let's take this Tesla Roadster and stick it in orbit around Ganymede. All right. So now the Tesla Roadster is in orbit around Ganymede. There it is. And let's just go grab it. And let's see if we can zoom in on it. First, I got to select it and get there. All right, here we go. All right.
See something blue in the objects on the left, and they're calling it a police box. Do you think that's
That's the TARDIS.
Copyright thing? Yeah, I was gonna say, yeah, but it's distinctly called the police box, but I was thinking TARDIS as soon as I saw it.
But you know what? You're right. They couldn't say the words TARDIS. You know, probably. But we can, and we do.
Okay, yeah. What the deal is, Paul runs a giant mall down in Miami. And that's the mall that he uses. The parking garage is what he uses to set up and whatnot. So the area that he's in, he has to go off of the mall internet. And the mall internet is only set up for like credit card sales and whatnot. So it's like it's not really a really fast broadband connection. So what he's doing is he's feeding it to me in the best resolution that he can, and I'm actually upcoding it to 1080p, which is why we get a little bit of pixelation and whatnot. But if you guys were to see the actual optics straight out of Paul, like we want to do here very soon, you guys would be blown away. It's so clear. I mean, these craters, I mean, it looks like you can just reach out and grab them, especially when we do the moon and whatnot. But for right now, we're stuck upcoding. We have thought about, we're waiting for wireless to get a little more advanced. We have looked into a couple plans with a 4G wireless connection, which would allow us to stream 1080p up to like, I think it's like 70 gigabytes a month. So, you know, that's kind of the reason we're stuck right now. I mean, in all reality, what you guys are seeing, I mean, though many consider it good, and it's not bad, you know, on clear nights, but it is nothing compared to what it looks like coming direct from the camera. And as I said, the cameras are custom made. As far as I know, we are the only ones that do something that we call direct optics, which is basically because most astronomers use the camera ports on the back of their telescopes or whatever, you know, and they can port it in, and some of them use Barlows and whatnot. We don't do any of that. We don't use any lenses. We don't use any filters. It's basically camera to mirror. So I'm pretty sure we're the only ones that do that. Like, as you can tell, this view right here, I mean, this is gorgeous. I mean, you really can't tell unless you're really looking at the edges that it's a lower, you know, that it's a lower resolution being upcoded. But yeah, once again, it has nothing to do with your what you're watching it on. It has everything to do with Paul's signal getting to me. And he needs to be able to stream, because I mean, the camera, I believe, is capable of Ultra HD. It's not 4K, but he does stream it to himself. You know, he has a big screen down there that he's looking at it on in Ultra HD, and it's just, I mean, it's nothing compared to what you're seeing now. So that's our biggest thing. That's the biggest thing we're lending funding to, is because if you guys ever looked up wireless stuff from like cell phone companies or whatever, you know, they're pretty expensive. You know, I think the cheapest one we found was from Sprint. It was like $60-some a month, and it was only giving us like 50 gigabyte. Now that's pretty hefty, but we're not sure it'll handle all the streams that we want to do. But it might be able to open the door for us to allow us to do most of our streams throughout the month on the Ultra HD, and then do the rest of them the standard way that we've been doing it. So, so yeah, that's the whole story with it, which is why you can see the pixelation and whatnot. But I'm just happy now that I'm not seeing a cloud, and I shouldn't have said nothing because there's probably going to be 15 of them flying across the screen here any minute. But yeah, so that's the story behind it, just so you know. So, but I do want to welcome you guys. Welcome Keith. I know you've been here before, and Blaine, and who was the other guy that was back here? I see Genghis is in there now. Who was the guy up here that was here a little bit? It was Scott Meyer. Welcome, guys. We were doing a kind of a dual stream with Marc D'Antonio a little bit earlier with Universe Sandbox, kind of just playing around. But once Paul said it cleared out a little bit, we knew we had to stream, because we've only got one stream in this month, you know, and this will be the second, and that's for the entire moon cycle, you know. So we know we had to jump at the chance, and hopefully we'll get maybe one or two more before this cycle's over. But keep your fingers crossed. If it does continue to get good and the weather gets better, we will be doing the Jupiter and Saturn streams, strictly Jupiter and Saturn. So look forward to that. So yeah, that's the whole story behind it. What's up, Jello? I see you joined in there, and let me jump here and back on and clean up these optics a little bit so the whites aren't popping so much. And yeah, I might jump back on a little bit, see what's going on. But as you can see, that was way too much to type, so I'd rather just told you. Alright, so there's the story, guys. So we're working on it. We're hoping to get it to you. It might even involve me going down to Miami and us figuring something out. with another local business or something, maybe teaming up with them and maybe paying half of their internet bill. Because the only thing businesses really need it for is running credit cards and maybe have just a basic internet connection for their corporate stuff and all that. So yeah, we're gonna figure something out. We've been working on it for a while. We're trying to figure out what the best option is, and the best thing you guys can do to help that out if you want to. Once again, you don't have to, but we do have the P&K Astro Wear stuff where you can grab a t-shirt or whatever, and all that stuff is going towards the internet stuff. So yeah, so enjoy. I guess we'll enjoy what we have for now, and then hopefully keep on upgrading as we move along. So thanks for joining us, guys. It's always nice to have some eyes. All right, I'll be back on in a little bit. I'm gonna clean this imaging up a little bit. Man, there's a lot of moisture in the air. All right, I'll be right back. Okay, well, Jupes is getting better. Little by little. I'm not sure how long Paul wants to go for tonight, so we're just kind of just winging it. Once again, for anybody that wasn't here earlier, we were doing a dual stream with Marc for Universe Sandbox 2, smashing planets together and whatnot, and Paul said a clear spot was coming and he was going to set up, so we decided to jump over here and see if we can't get some imaging in tonight, which is what you're viewing right now. I do want to say what's up to Disclosure and Duplicate and Ted, and Nancy, and Mr. Culpepper, Keith, and yeah, dude, no big deal. I mean, you could have left your name, you know, the way you had it. It's no big deal. I mean, lots of people have the same name. Definitely don't do it on our part, you know. Let's see, Marc was here. I'm not sure if he's here anymore. Jello was here. He headed out and tried to get some sleep. That Keith earlier was actually me from my other channel. I had to jump in there to get the link real quick. So we don't have to worry about that. And D, I see D stopped in. Another D, that's our second D. This one's DS. I'm guessing it's standing for initials, but spelled out. And thanks for ordering the shirt as well. So that's cool. Mr. Culpepper. Yeah, and that's what I'm saying. We make a little bit off of those, and then, you know, we're going to put that in and hopefully get this internet issue fixed. So, the GRS, I don't know, I haven't looked. I think somebody said earlier it was going to be around 4 a.m. It comes around, you know, pretty much every 9 hours, so you figured it takes 2 or 3 hours to actually cross the face. So let's just say safely it pops into view every 6 hours. I'm not sure when the last time it was out. So but man, the lines, look at the bottom dark line, the one that's defined pretty well, but I don't ever remember seeing it like that. Now maybe it's just because our resolution's a little low tonight because of all the moisture in the air, but look how crazy that gets towards the right side, how it kind of goes up and then down. That's really awesome. And that was Paul texting me, so I'm wondering if he's looking to end soon, maybe not. He's just asking how everything's going. Dun, dun, dun. Just text him back. I hope everybody had a good Memorial Day. If you're from the States, I had a nice relaxing one. I didn't do anything. I didn't bother with any barbecues. I did mop my kitchen floor though. How exciting. Keith, you're asking the wrong man. Marc was just here. I believe there is a good amount of hydrogen locked up in Jupiter. It is gases. Oh, and this phone just needs to stop. Oh, let's see what we got here. Okay, good. Everything's good. You didn't mention anything about stopping, so I guess we're going to stick with it for a while, even though it is after midnight. It says we've been streaming for 3 hours, but almost 2 hours of that was with Marc. We've been doing this for about an hour so far. And Jupiter's going pretty fast. I mean, the spin has to go pretty fast in order to even make those bands. So, once again, I mean, Jupiter spins on its axis every 9 hours. I mean, that is super fast. You figure it takes us 24 hours. So for a planet that size, it's moving. Just an amazing planet. And you know what? If it wasn't for Jupiter, I don't even think we would be here. Because we in the astronomy world call Jupiter Earth's big protective brother. It protects us against a lot of meteorites, a lot of interstellar objects. Its gravity alone can throw off a lot of objects from coming into the solar system. And it's just sitting out there, kind of our protector, along with Saturn. But man, I tell you, when we do get it clear, it is just, it's breathtaking. And it looks pretty clear on the YouTube feed. I'm looking over at it now, and it actually looks a little bit better than what it does on the OBS feed here I got. But it's coming out pretty good. Not too bad with a sky loaded full of moisture. which is why we're getting all kinds. It's hard to focus when there's a lot of moisture in the air. And he's doing a pretty good job. Paul just keeps getting better and better and learning how to compensate for certain weather conditions. Yeah, and if you notice that storm has actually been shrinking over the last 20 years. If you remember, I'm not sure if anybody's around my age. I'm pushing 40. You know, I just turned 38. But when I was in school, that storm was a lot bigger. About 20 years ago, and it has been shrinking. And scientists think that it may end up disappearing altogether in the next 20 years. Now, that's not saying it's not going to balloon up somewhere else on the planet, or maybe in a different band, but it has been shrinking. And now Paul goes back to our old friend Luna, our trusty companion. What a gorgeous sight to see after all these clouds. It looks like, I mean, it cleared, I mean, for the most part, it cleared pretty good in Miami. I think the next band of clouds that comes through, I think that's when Paul will call it quits for the night. But as of right now, we're not doing too bad. So whoever has their fingers crossed, keep them that way. Now, let's fix this imaging, because as you can tell, this is what we call an over-contrasted image. The dark spots are dark, the light spots are real light. It does give a cool look, and the more that you do it, you know, it almost gives the look of cities or structures. I've seen a lot of people claiming when you over contrast stuff. We're gonna leave it, and if you want to see what it looks like without our processing, because we do, you know, process it on this end to make areas a lot more visible. But if you want to see it, because it is full, and once again, full moons are horrible for imaging the moon, unless you're doing like a full shot, which is why a lot of people go out on full moon nights with binoculars or whatever, or lay out and just look at the moon, because it's really pretty. But for us looking for artifacts or looking for UFOs, they're horrible because it's just flush with light. But this, let me put it on here for you. This is what it looks like without any of our processing done. It's bright. It's real bright, you know, and it's really hard to see. You know, you can't really get, I mean, it's still pretty, but really, really hard to enjoy, which is why we do this on this end. We take everything down. Usually around the full moons, I'm running negative brightness. But I do take the gamma brightness up a little bit just so I can put that contrast in. And to me, right about there is the perfect moon shot. It has good contrast. It's not the whites aren't overly popping out and basically smoothing everything else out. The darks aren't overly dark. You can see Aristarchus down there to the left hand side. So yeah, but here's where we have the problem with the moisture. As soon as he tries to go in, the closer you get, the more you're gonna notice it. But once again, it comes in handy doing stuff like this, so you can see, like, we can really make Aristarchus pop out over there, you know. As you can see, this right here is Aristarchus, for anybody that doesn't know. It's one of the brightest points on the moon. And I was always fascinated with Aristarchus because it almost looks like a cookie cutter cutout. It's like a perfectly square area, which they call the Aristarchus Plateau. And if you look at it up close, which we do have very, very good up close imaging on this channel, you might have to look for it a little bit, of that area. And still, the closer you get to it, the more it looks like somebody cut it out of somewhere else and just placed it there. It's a really interesting area. Nancy said it looks like a cantaloupe. I can see that. But man, look at Tycho. Look at those rays coming out of Tycho. That was a big impact. Just imagine the kinetic energy involved in that impact to send those rays out as far as they are. Now, granted, the moon's gravity is 1/6 of what it is on Earth, so they did have a little help in that essence. But man, you're talking from the center of Tycho all the way to the top of where that top band is. Anyway, that's almost 2,000 miles. I mean, that is a big crater impact. And yet, there she sits. And a lot of scientists actually think that initial impact from Tycho, if you see all the little pockmarked craters around the moon, the debris from Tycho actually might be some of the stones re-entering and hitting the moon after the initial Tycho impact. Which you could say about, a lot of the bigger impact, Copernicus, and even on the backside, the backside of the moon, or the far side, we will not say the dark side, but we will say the far side, is totally pockmarked. You don't have Maria on that side. It is literally crater, crater, crater. And how awesome would it be if we can get a live feed of the backside of the moon? I don't think it's impossible. It'd be expensive because you would have to send 2 satellites pretty far out on each side of the moon, and then a satellite to the far side of the moon. But your 2 on the sides would have to be out far enough to receive the signal from the camera on the far side of the moon to relay it in real time. Have I seen moon clouds? You do get, they're not really clouds. Some of them are venting, which NASA actually has a couple videos as well. But would I call them clouds? No. And the closer and closer and closer you zoom up, especially if you don't have the resolution, like the scope that Paul uses, the 9.25, which is actually the wrong one that's on screen right now, but the big scope, as we call it, we get better resolution with that than a lot of people do with the 10, 11, 12, 14-inch telescopes because of the camera. And that's after Paul has done a lot of testing, and I believe he was using a DSLR for a while and just realizing that that's not going to cut it. DSLRs are good and everything; they'll give you nice resolution images, but when you go and try to zoom in by hooking one to a telescope, it's not going to work out too good. You get a lot of artifacts from the camera. You get a lot of pixelation. You get a lot of thinking there's artificial structures. It's because of the optics of the camera itself. And if you're going to use one for the moon, you need to have a pretty expensive, a $500 Canon is not gonna, it'll give you a nice, a wide field picture of the moon, but it's not going to give you really good up close pictures. If you really want good up close pictures, you need to, the camera itself is probably going to cost you around $3,000 to $4,000 easily, to have everything that you need in it in order to cut the light out and even everything out and to give you a good solid image. Besides that, you're going to get a bunch of camera artifacts if you try to zoom in with a regular DSLR, whether it be Nikon, Canon, it doesn't matter. You're going to get a lot of hexing, as they call it, which if you take an image with a DSLR and you zoom in on certain areas of the moon and you actually take a picture or take a video, if you try to process that afterwards, you're going to get the hexing. You're going to see the hexing involved with the pixels. And it looks like just straight little boxes, whether they be hexagons, whether they be squares, whether they be straight lines. A lot of people mistake that for pixelation, but it's not. It's actually an in-camera artifact that you get. So yeah, but at least we're getting the moon tonight, guys. I'm kind of just rambling on. I don't feel like typing anymore. It's been a long night. Let's see. Perfect stutter. Perfect stutter, that's a different name. That right there is Aristarchus. For anybody that doesn't know. Most people know that's Aristarchus. And if my memory serves me correct, it's the brightest point on the moon. I could be wrong about that, but I believe it's the brightest point on the moon. With the naked eye, if you're standing, it's one of the brightest spots you can see. But look at that. Doesn't it look like somebody just cut out a square and placed it there? Like the dirt's running the wrong way from the rest of it. And I can map it out for you right here. Look at this. Tell me if you do not see this square and how it looks completely different from all this around it. Everything in here is different than what's around it. It's really freaky. Where did the Chinese rover... I'm not exactly sure the exact part where the Chinese rover landed. I know we could probably look it up and find out exactly where. I mean, it really ain't going to make a difference. I mean, no Earth-based telescope can see them anyway. That's why you don't see us, like, zooming in on Apollo sites or anything like that, because you just can't. We don't have the resolution to do it. If you were to try to basically see any of the Apollo landing sites from Earth, you would need at least, at minimum, 100-meter telescope to resolve that image from that far away. And even with a 100-meter telescope, one Apollo site would only be like 2 pixels. That's it. 2 pixels. So it's we just don't have it. I think the biggest one we have or will have is like 30 meters, and that's going to be at the large telescope over in England when it's finally done. I think that's going to be the biggest on Earth. Now they can link 6 or 7 or 8 or 10 or 12 telescopes together from all around the planet that all see the moon at the same time, and you know, kind of point them and make a solid image out of all those. You might get a couple pixels out of it at that point, but they're not going to do that. Telescope time is too cherished for astronomers for them to be trying to sync up and look at the moon. So let's see, who's the background music? I have no idea. It's a YouTube playlist. It's all YouTube's free, copyright free stuff, so it just gets put in a playlist and just played. You know, I give the parameters of what kind of music, you know, and I try to keep a good mix, but yeah, it's just a copyright free playlist. You can get them off of YouTube themselves. Let's see, China sending another rover in November, yeah. To the dark side. It's not the dark side, it's the far side. Communication satellite was launched. Yeah. I think we need to pay attention and go back to the moon more, actually. That's my own personal opinion. I'm not sure why everybody's concentrating on Mars so much. I think it would be so much better to have a operational base on the moon, because it's so much easier to launch stuff off of the moon because of the less gravity. So if you could get like a depot on the moon and actually send people from Earth to the moon, get them prepped up and have a lot of stuff, you can launch way more off of the moon. I'm talking about payload of food and water and everything like that than you would be able to from Earth. So they could, you know, run 20 missions to the moon supplying, say, a depot there, and then actually find a way to get another vehicle there to land, and then to load them up with all kinds of stuff with, you know, way more weight, and then launch them to Mars from the moon itself. I think it would be way better, but that's just me. What's up, Shay? I should say what's up to everybody in the chat. I can't believe there's still a lot of people watching. Let's see, what do we got here? What we got is over contrasted moon. Let's take care of that, shall we? There we go. We got Ted and Duplicate and Shay and Perfect Stutter. Let me see who's in the participants list. Oh, not too many. Jody, and that's about it. Ted, Perfect Stutter, Jody, Duplicate, and Shay. That's an active participants in chat. But we do have almost 40 people watching, so the people that are watching, you're just as appreciated. The extra eyes are always awesome. Do the polars have ice? Yeah, they have discovered ice on the moon. That's why they crashed that satellite into it years back. And hello, Christy. Welcome to Live Astronomy. I know, well, maybe I'm thinking of Mars. I know they discovered ice in the caps of Mars, but I believe they did on the Moon as well. But once again, I could be wrong. But man, we got lucky tonight. Remember all the clouds that we were having earlier? They're staying away. The air is still active. It's still filled with moisture, so we're getting a lot of movement, but it's not bad. Yeah, Ted, good point. Absolutely. Any of the people viewing, you're more than welcome to join the chat. We try to keep it a friendly place where everybody has a voice. Hello, Norma. The only ones we really don't give a voice to anymore is the flat earthers, because they just turn out to be ignorant. We do have some friendly flat earthers that, you know, we'll have discussions with and whatnot, but for the most part they just come in, and then once they realize that they're at the wrong audience, and they get kind of defensive. And let's see, do you watch any of Bruce Schwartz's moon videos? Yeah, I have seen a couple of Bruce's stuff, you know. And once again, I did make a statement on Bruce before, but I'll say it again for you guys. I love what Bruce is doing. I like his enthusiasm. I don't necessarily agree with his findings or his methods, but as I've always said, the more the better. The more eyes looking at the moon, the better. Whether that be through us, through Bruce, you know, through Take Back Space. He's a good friend of ours. So, yeah. You know, more power to him. But once again, I can't say that I agree with his findings or his method of finding, because a lot of that stuff can be explained. But you know, either way, I mean, he's just searching for the truth like the rest of us, right? So the more the merrier. I encourage everybody, even everybody in this chat, I encourage you to get a telescope and be watching. Because you never know. I mean, that's the main reason why we do this. We're looking for stuff. We just choose to do it on a scientific front. You know, we just like I said in the KGRA interview, you know, we want to find that kind of thing, but we also want it validated. And if we can get, like, if we capture something on these streams, and we can get it validated, because it'll be sent to Marc, and if Marc can't get it and he finds it good, then it gets sent to colleges. Like, we have protocols in place for if we catch something, you know, totally unexplainable. If something comes into the screen right now, stops and shoots, you know, 90 degrees in the other direction, you know, it's going to get checked out, you know. And that's everyone's goal, you know. That's our goal. That's Bruce's goal. You know, Take Back to, I mean, everybody's looking for that, you know, what do you call it, the light in the storm. You know, we all want that. But once again, if something comes across the screen, we're not just going to yell out aliens. You know, it's going to get scrutinized. It has to be scrutinized. In this day and age, the way ufology is these days, with everybody calling everything, you know, aliens and, you know, what you call, I mean, I'm a believer in extraterrestrial life. I believe we are being visited. My goal and Paul's goal here with this channel is to prove it through the scientific method, not just guess. You know, and there's stuff you have to do that. And yeah, it sucks when you find something and you think it's awesome, and then you go and, you know, all of a sudden it lines up with known satellite data, and you're like, ah, crap. You know, it was a satellite. It was just a weird perspective. We were looking at it. You know, yeah, that sucks, but, you know, what can you do? But what I can stand is when these, you know, big UFO gurus come in and steal clips of satellites crossing the moon that we have, and all of a sudden they're putting it all over the internet that it's, you know, an alien ship, and next thing you know, the UK tabloids get a hold of it, and next thing I know, there's 16 headlines saying, you know, observatory in Florida, which is wrong. We're not an observatory. Catches crazy thing flying past the moon, or aliens, life past the moon, blah, blah, blah. You know, it's all about clicks for them, because that's how that's tabloid business model. You make them click, that's when they get the ad dollars. So, but, yeah. So, guys, I mean, we're all searching for the same thing. Right? So good luck to Bruce. I hope he finds it. But once again, I don't necessarily agree. I wish he would live stream. I wish he would do it live. I mean, that's the main reason we do this live. Because if we, okay, say we're all watching right now, where the 32 of us are here watching, and something comes in, stops, does a 90-degree turn, and shoots off. Okay? Now, that's 32 of us that see that. Now, tomorrow, then I would take that clip after we're done the stream, and I would isolate it into a clip of its own, and just do a little more in-depth look at it. So what I would do is I would take it and I would put a zoom video out, you know, on it, just, you know, zooming in on it, contrasting it, trying to figure out what it is for everybody to see. But the point of the live stream is, if somebody comes across that video that wasn't in the live stream and thinks it's CGI or computer generated or something like that, we can literally point them back to now approaching 4-hour live stream and point them to the exact time that it happened. And now we have chat replay. They will see all the chat that happened at the time. They see all the information on screen, from the direction to the altitude to the time down to the second. They can, you know, collaborate that, all that information, all that stuff, which gives it validity. And that's the main thing with this channel, is we want to have validity. We want to validate what we are seeing. Now, if somebody records the moon and then is constantly, you know, putting up videos afterward, that's fine, you know, but that's the first thing that's going to get called into question if he finds something miraculous. Okay, so you know, we could sit here and not stream the moon at all and just upload the actual videos of the moon stream, and the first thing that's going to get called into question is because that footage can be tampered with. Now, I'm not saying live streams can't be tampered with. They can, obviously. I mean, I think I put a flying kid on a pickle one time flying across the screen. I mean, it's a lot harder to do it live, but I mean, it can be done. But as soon as they find out that the only eyes that saw it before it hit the internet was the person who made it, that automatically throws up red flags. And I'm not saying that anybody's doing that. I'm just saying, as an investigator, as talking to MUFON people, that's the first thing that's going to come to mind. Is, okay, was this footage manipulated in any way? Was somebody outside throwing a freaking, you know, a frisbee or something like that? So we always want this as a backup. And this whole live stream, you know, I'm sitting here in Pennsylvania. There's no way I'm manipulating it. I can't go out and throw a frisbee in front of the moon. Paul's down in Florida on top. Like, you know where we are. I'm guessing Paul could throw something if he wanted to. But he's too much about actually trying to find legit answers that, you know, that would almost be sacrilege to him. So, you know, and even so, even if he could, even somebody with the strongest arm, and if they were good enough to actually throw it in the path of the scope, because you got to remember, if you go outside and look at the moon, even a full moon, you can see the entire moon with room to spare through a drinking straw. You realize how good your aim would have to be? So if somebody, say, threw a frisbee or a ball, that thing would cover, you know, half of the moon, if they were lucky enough to even get it in front of the moon. So most of the time, but then you got to look at all the people that, you know, are faking UFO videos, and there's a lot of them out there. And then you have the UFO channels that promote the fake videos just for views, and the whole thing gets flooded. The whole field of ufology gets flooded, and then we get to the point where we are now, where, you know, what can you do? So we're trying to take the best route that we can for validity. Not only for us, but for anything you guys see. You know, if something happened right now, you realize how hard it would be telling people that weren't watching the stream what happened without video proof. You know, let's say Nancy, you know, is here and does something crazy in front of the moon, and then she tries to go tell the neighbors down the street, hey, you all see what I saw last night? I saw a UFO cross the moon and do a 90-degree turn. What's the first thing the neighbors are going to think? Oh, crazy Nancy watched something on YouTube. You know, somebody made a video of a flying saucer, you know, flying past the moon and doing all kinds of crazy stuff. But if Nancy can go down there and say, no, well, here's the isolated video of the object, and here's the actual 4-hour live stream that you can corroborate the times, then once again it gives it a little more validity. I don't know. Call me crazy. And I'm pretty sure there's more stuff we can do, and I'm hoping that we do it. Once again, just to try to keep science involved, try to figure out what these things are, and if we can identify them, we're gonna identify them. I mean, as much as it sucks, if we can identify an object that comes across the moon, we're gonna identify it, and we're gonna say what it is. Hopefully before the UK tabloids get a hold of it and, you know, run with it. Because nobody cares about the backstory. Nobody cares about, you know, the information after the tabloids get a hold of it. And they don't do retractions. And I'm not going to spend my whole days, you know, running down tabloid, you know, comment section saying, no, this is actually what happened. This was us. We have figured it out since then. We know what it is. Blah, 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 yada, yada, yada. So yeah. So hopefully, with everybody that's here and everybody that's subscribed, you all are going to be part of history if we do happen to catch something one of these nights. And oh, what a night it would be! Because I mean, you got to realize, just mathematically, the more we watch the moon, the better chances we get. Like, we're upping our percentages of seeing something. You know, they get better and better every time we stream. So figure that one out. And man, are we getting lucky right now. It is staying clear. Sheesh. Oh, Paul texted me. Let's find out what that was all about. Okay, he's putting away the big scope because the clouds are moving in. So he's going to stay with the wide the rest of the time, guys. So I think we're pretty much done with Jupiter. But we are going to stay with the wide field until the clouds come again, and then we'll probably end it for the night finally. So what I'm going to do is I'm going to take a break and get a drink, and maybe I'll jump back on with you in a little bit. Sorry for the rambling. At least you had something to listen to besides music, right? Alright, guys. I'll be back in a couple minutes.